morning, everyone. Let us start our day 3, session 1. The topic for this session is Big Data Analytics in the context of IoT. Professor Sumit Kalra from IIT Jodhpur will be the resource person. Dr. Sumit has done his BTech from Punjab University in Computer Science and Engineering, and then he has pursued his MTech and PhD from IIT Kanpur in the same field, that is Computer Science and Engineering. His research interests are software architecture, data analytics, IoT, smart healthcare. I would like to welcome Professor Sumit Kalra to add glory to this atmosphere and to develop the skill of excellency. Welcome, sir.
Welcome, Sumit sir.
Yeah, thank you. I'll share my screen. Good morning, everyone, and thank you for the kind invitation and introduction. So let's start with today's topic, big data analytics from IoT perspective, and little bit about my lab and my work at IIT Jodhpur. So we are part of Software Innovation Lab, and there are a couple of PhDs who are working with me in various areas. Some of the work which we did related to IoT is telemedicine portal. So we launched it within 1 month of the initial lockdown in March 2020. And the key aspect which we incorporated here is we can use IoT devices to integrate with our portal, and doctors actually can measure vital body parameters remotely for a patient. So that was the IoT aspect, and we deployed it for IIT Jodhpur PHC. We also deployed it in a village in Sundarban area in West Bengal, and we also took it forward through Unnat Bharat Abhiyan to various rural areas. And as you can see, it's going to be used in rural areas, so it has to be supporting Indian language. So we currently support Hindi, Bangla, and English. So where is the language in the telemedicine portal? So this portal is also having a chatbot, and chatbot tries to extract as much as information from the patient so that we can present the summarized information to the doctor instead of wasting his time in asking conventional questions. And we got 40 plus doctors registered on the portal with various expertise. More than 500 patients with multiple revisits have been benefited, and we have total around 9,000 visits, and we are also supporting thousands of audio video calls simultaneously, and still our computing resource consumption is less than 10%. So that was a challenge here to build an IoT support system which can be scaled up, and along with some linguistic features like Indian language support. And of course, in this mobile era, it's mobile friendly, user friendly. You can upload clinical reports, pathological reports, and doctors can see. So all those features are there. And the portal is up and running. And it has been up and running since last 2 years. The second work which we did related to crowdsourcing, not exactly IoT. So we have Fake Finder app on Google Play Store. So what is so during COVID only we observed that lots of rumors are there related to COVID. We should follow this. Some random home remedies were there. Some were useful but some were not that useful. So we built this app where you can copy paste any social media message from any other mobile app, and this will send your message to a server where we are running this fake analytics, and it's a crowdsource based, so other people can also vote, and there are experts who can vote also whether a message is fake or not. An expert will have more weightage in their votes. So let's move to the today's talk. So the outline is, we'll talk about why the problem is dominant. Then we'll talk about data intensive systems, and we'll look at some state of the art work. So look at a data intensive system from a IoT perspective only, and then state of the art tools framework which we are using and currently popular in the industry. And then we'll talk about some key approaches these systems deploy, and then some open issues. With that, I will end my talk. So let's look at the IoT system, why they are critical, why they have, what kind of special needs are there. So we'll also look at the various IoT services, and we'll look at the relationship with data analytics and big data in IoT. Then we'll look at various big data IoT frameworks. So let's spend some time in uh, understanding what is IoT system from software point of view. So, and in real world, you have physical objects. These physical objects can exchange data through a communication protocol. So, like we are exchanging our communication, I'm using the language which is comprehensible to everyone. So, we are having some communication protocol like the language grammar, and data exchange is the information which we are sharing. So in the real world also, these physical objects have to have compatible communication protocols. So if I use some other language which is not comprehensible to the audience, I won't be able to communicate what I want to convey. So in the same way, in physical objects, if two objects are using the same protocol, then they can talk to each other, exchange information or data. And if we look at the kind of system we have, these physical objects are coming from different vendors, and it is, you know, uh, critical to have a standardized protocol so that every vendors follow the protocol, and uh, things can talk to each other. Let's take example of Bluetooth. So different mobile phones with different vendors can still exchange data using the Bluetooth, because Bluetooth is a standard communication protocol. Uh, Having only compatible communication protocol doesn't suffice. You need to have data exchange formats uh, which can be understood by each object. Say one mobile phone, if it doesn't understand JPEG format of an image, then doesn't matter you exchange the file through Bluetooth, the other mobile won't be able to, you know, understand the JPEG format, and they can't utilize it. So apart from communication protocol, it is also critical to have common data exchange formats which are comprehensible to both the objects. No, actually, physical objects can't communicate without software. So they themselves doesn't have any capability of communication. So software makes them enabled to communicate with each other. Then software, we can hard code some information that software can exchange, but that is not that useful. So we have sensors. So sensors sense the information from the environment and pass it to softwares. And software can make some decisions based on these sensor values and then communicate. Now, this is again limited capability. Sensors can uh, only, sense the environment. They cannot act in the environment. So we have actuators, and these sensors and actuators can be controlled uh, by the software. So physical objects having embedded software, sensors and actuators in combine, and then having common, standard communication protocol and data exchange protocols formats. Uh, that's what the thing. It will make the IoT, Internet of Things. So communication protocol and data exchange happens over network, and physical objects have sensors, software, and actuators. Actuators can be simple LCD display, need not to be always a robotic hand. So anything which physical objects can use to convey information to the environment. So if we are using your mobile screen is actuator actually, because it's displaying something and based on that you are acting. And your touch screen is a sensor, your gyroscope, proximity sensor, all these are sensors. And of course, your Android operating system or iOS is software part. So combining everything will make Internet of Things scenario over the network. So let's look at the IoT services. So I'm just using a few sentences from Gartner research. I'll just read it and we'll spend some time on it to understand what are the different needs of IoT in the context of big data. So it says that the Internet of Things will do just that by producing unprecedented volume, velocity, and variety of data. We'll see what it will do. This will force organizations to re-architect their data and analytics capabilities, adopt new data management technologies and platforms, and create new data governance policies and practices to act upon all of this data. So now let's spend some time and understand what does it say. It says that IoT will do what it will do. It will change the policy later after the second sentence describes. And why it will do? Because it will just produce unprecedented volume. So IoT systems can easily produce huge volume of data, huge velocity of data, and with different variety, heterogeneous data. And how it will generate large volume. You can simply imagine nowadays everybody is having a smartphone and a smartphone generally have, 5 or 6 sensors like touch sensor, proximity, gyroscope, accelerometer. So with this smart home system, a smart city coming in, what we have is we'll have more number of sensors, more number of devices per person. If you generally say in next 3 to 5 years, single person who is connected to internet will have approximately 50 plus sensors, one person. When currently, if you look at everybody is having a smartphone, maybe a laptop or tab. Anything. Now, in the same way, the velocity, the data generation speed is also quite high. The variety of data is being generated, like cameras generates multimedia data, other sensors generate maybe numerical data, statistical data. Now, what does it will do? It will force organizations to re-architect their data and analytical capabilities. So conventional data processing system and analytical frameworks will not be successful. It will also force organizations to adopt new data management technologies. So data management, you must have heard about data is the new IT. So everybody is running about data. I think some noise is coming from someone.
কালকে যে মেয়েটা দাঁড়িয়ে ছিল মেয়েটা কোথায়? কালকে যে মেয়েটা দাঁড়িয়ে ছিল, কালকে একটা মেয়ে দাঁড়িয়ে ছিল,
I request to mute. Yeah, thank you. So data management technologies and platforms, we have to revamp everything. The conventional one, older one will not continue to work with new type of data or new variety of data. And then it also enforce new data governance policies. You must have heard about digital data privacy laws coming in many countries. European countries has brought GDPR, which is data privacy law. Yeah. So as more and more people are connecting to internet and they are sending lots of data to network or cloud or server. So these issues are becoming a real challenge in the modern world. I'll just share one small example. Uh, I went to see a doctor and it was offline visit and the doctor was ENT and to my surprise in the same evening when I was surfing over my mobile phone through browser, the kind of advertisement I was seeing is related to some hearing aid or some related devices and all. So although I was not using any telemedicine portal service, I physically met the doctor and still somehow these companies got to know that I have visited ENT doctor and they started showing me ENT related ads. But data privacy is a huge concern in the modern world. You don't know and you will maybe never know what all data is going there and what all information the agencies are using. This is currently being used heavily by credit card offers or banking offers, sales, marketing advertisement. So I'm not aware what sensor data was being used to track my activity, but I doubt on my mobile phone. So if you are having a smartphone, you can easily assume that uh, your privacy no longer there. Your data is being shared every moment. So that lead to next topic, uh, big data. I'll just define what is big data. As you can see, big is not a technical term, it's a relative word. So today's big might not be future's big. And what was bigger 10 years ago is not anymore big thing in the digital world. So there are various definitions uh, which uses various ways to signify what is big data. Some says 3, 5, or 7. So I have used middle path. So I'm taking these 5 P's and we'll discuss what is big data. So volume. So volume says your data will go into large amount, terabyte, exabyte, zettabytes. Now, if you see what is big today was not big, was actually the big earlier was not a big today. For example, I remember when I bought my first computer in 2005 in India, the maximum RAM available for commodity hardware was 256 MB RAM, and I got 128 MB RAM, which was like top 1% of the crowd is having 128 MB RAM. And the processor was P4, and the size of hard disk was I think uh, 32 GB. So you can see today 128 MB, 32 GB storage is not that big now. In fact, our pen drives are having more storage now. Our mobile phones are anyway is similar to our laptops in terms of storage offering. So if uh, 15 years back, if I say 1 GB data is huge, people must have believed that yes, 1 GB data is huge. But today people will laugh. So that is what volume relative here is. So today we can easily say exabytes or gigabyte data is large. Terabyte data might not be that large. So we are getting so many servers with terabyte storage and few hundred GB of RAM. Then second is veracity. So veracity indicates the truthness or some value in the data. So data in its raw format is not that useful. Data is not that useful, uh, which doesn't have much value. So uh, we have lots of uncertainty in the sensor data, especially in context of IoT. Veracity becomes more prominent because if your sensor is giving you some random value, it's not that useful. So then many times sensors may not send uh, the value, so it may not be present all the time, and many times it can be inconsistent because of various environmental reasons. So uh, truthness in the IoT data becomes the challenge. And if your network or sensor data is random, uh, so there will be lesser veracity, and we should not say that that is leading to big data. That is actually leading to some random data. Then we have velocity. So volume and veracity is not enough to claim any problem as a big data. It has to have uh, high speed velocity. So velocity refers to the data generation speed. So you should, if your system is having large volume of data, and if that large volume of data is also having some information, but if it's not being generated with high speed, we may not call it big data. So uh, big data is like uh, if your velocity, suppose you are generating 500 MB of data, 500 MB of data uh, every uh, every day. You should not call it, big data. So, uh, so all these features are necessary uh, to call, the next feature is variety. So, in the variety, uh, we assume that your sensors are giving different values of you cannot assume sensor will give you, all sensor will have, you know equal frequency of data. So data can be structured, unstructured, or multimedia. Value. So veracity is truthfulness, and value is whether that truthfulness gives you any, or it can act based on that data or big chunks of your profit. So all these are compulsory for big data. Volume, veracity, velocity, and value. I hope all these V's and their significance is clear to all of you. With this, two things in mind will move forward. So, just a quick revision. What we have seen so far is uh, what is IoT, how we define IoT system, and then we have defined big data. When we call it big data. Now let's look at the big data analytics. Now, given that you have large amount of data, the next step is, of course, the data processing, but that is always necessary. After data processing, we go for analytics. So let's understand how analytics in the era of big data is different from the analytics conventional. conventionally. So if you look at the uh, you know last century part of computational progress, you can call it big data phase one. So during that time, most of the database was based on relational, and as you know, relational database structure are generally having fixed schema, and to manage large amount of data warehousing concepts were there, and the key process which was there in IT industry was ETL. ETL stands for extract, transfer, and load. So what was happening during those period was they used to extract data from somewhere, they transfer the format which is suitable for the destinated system. Then you load the data in the destinated system where you run your queries, relational queries. So online analytical processing system, OLAP, OLTP were there, and the key utility was dashboards and scorecards. And we had conventional data mining approaches and statistical analysis approaches during that period. So many of you have seen, must be aware about this phase. The we are currently in transition between phase 2 to phase 3. So in phase 2, in early 2000, when .com boom, uh, we started having web-based platforms. And as you can see, web-based platform is combination of structured data as well as unstructured data. And during this period, information retrieval and extraction used to be key process. And then since web-based system allow people to also generate content, earlier if you see the web-based system before 2000 era, user was not allowed to generate any web content. It was almost everything was uh, statically defined by web programmers. But in phase 2, we have web-based unstructured content which is generated by the crowd. So based on crowd, now we started with opinion mining. We also had QA sessions. Answers. Today, nowadays, if you crawl Google and you ask any question, say who is Sachin Tendulkar, so it gives you a specific answer apart from the web searches. So that was also started. Lots of websites were based on QA only, like various forums, Stack Overflow, or even Quora is fully based on question answering. So all these web applications created the need of web analytics and also to some extent web intelligence. So in web analytics, we try to monitor what user is doing and how it's doing and predict something. Then during this era only we seen the advancement of various social networks such as Google Plus, Facebook, Orkut. they also came into picture and they started fields like social media analytics, social network analytics. Then during this period, the information was con- getting continuously generated, and it was sensed that the temporal information hidden in this data is can be also very useful. So we had a special temporal analysis during this era, and the current phase which we are seeing the transition to phase 3 of big data. Now, most of your data is coming from mobile devices, not only cell phone, other mobile devices as well. And data is also the nature of data was earlier like human generated, now it's mostly sensor generated. And apart from temporal features, we have location based features also, and then personalization. And with personalization and location, we have bigger context because now we are also maintaining the history. So we have contextual information with us. Then the devices are of various size and everything has to be on a mobile. So mobile friendly visualization. You cannot show conventional data analytics result on mobile. So it's require rethinking. Then with augmented reality and virtual reality, we are having this human computer interaction coming into picture where there are seamless ways, not only touch, even gesture, or even if you just look at something or think about something. We have devices which can capture these human uh, body features and allows to communicate in more natural way as compared to the current way which we are interacting with machine is mainly either typing, and in recent years it has also become like audio, but other senses like smell, uh, all these things, facial gesture, we are still working on it. So AR VR allows you to have human computer interaction more immersive way. So that is again an idea about big data analytics, how it is moving since last 50 years. So let's look at the relationship between IoT and big data analytics. So as you can see in the diagram, uh, we have IoT system. It can be cloud based or it may not be cloud based always. It can be decentralized IoT system, and a large amount of sensors of various types leads to increased data complexity in terms of velocity, volume, and variety. Just hold on, I'm getting a urgent call. So this IoT system leads to much more complexity of data in terms of variety, volume, and velocity. Uh, Like I mentioned, there are large number of sensors, so it leads to volume, velocity, and sensors of different types leads to variety. And all this data will be required to generate various reports to query to the data and analytical tools. And with this AI and machine learning, this system requires to generate data which can be machine consumable to train machine learning models. So what it leads to us is we can now correlate big data with IoT. So there's a real-time data which can be unstructured, semi-structured, or multi-structured, and of course the amount is also large. And generally, the kind of aspects we look at for IoT data is time space correlation in the sensor data, and since sensors are generally low cost, not that reliable, so we may have high level of noise and redundancy in the data. And then of course we have continuous data stream coming in, so we have context driven nature of data. And your sensors can also be intelligence, so they can give you we can have context driven data. So it will to big data in real time. So that is big data in IoT. It takes us to big data system. Just hold on. So it leads to data intensive systems. So data intensive systems will look at the multiple aspects of data intensive system. Hold on. Just hold on. I'm having some emergency. Yeah, so sorry for disturbance. So yeah, so data intensive systems. Uh, yeah, so there was some interruption because of some emergency. I hope now I am audible and visible. Hmm. Yeah, so data intensive systems will look at big data, parallel processing, and its different architecture. So we have seen big data definition already, and the way conventionally we deal it, we do parallel processing on the data, and it leads to further complications, for which we require customized distributed architectures. So this is an example of distributed data intensive system architecture. Hadoop. Hadoop is quite well known in the industry, and many people are using it. Although now it's being replaced by more newer part, but Hadoop was the one who lead the industry in a big way. So as you can see in the Hadoop data intensive architecture, uh, there were there are various data nodes at the infrastructure level, and these data nodes have different small nodes, as you can see in the figure in the bottom part. So data node is the uh, storage facility, and you can also call them worker nodes, as most of the processing will happen generally on data node itself. And on top of data node, we have DFS clients. So DFS stands for distributed file systems. So these distributed file systems are capable of dealing with the files which are spread across multiple data nodes. So single file will be partitioned and will be stored across multiple data nodes, and that too in multiple copies. Because if we only store single copy, there's a chances of data loss. So we have large amount of you know uh, redundancy in these data intensive systems to increase the reliability. And then on top of DFS, we have uh, H files. The H files are logical files, logical unit of file. Actually, they are stored on DFS, and physically they are translated on data nodes. Then you have memory stores and multiple Hadoop regions, and each Hadoop region will have multiple clients and one H master which is controlling all the communication between all these clients, and zookeeper is there to take care of their liveliness and their availability. So Hadoop is an example of a complex distributed system which has been simplified over the years. So it's a very abstract level of architecture which I am showing here right now. We'll discuss more tactics in detail in subsequent slides. And so we are going to look at various architectural tactics for these data intensive systems. So features of data intensive system, like we have seen the example of Hadoop. So how they are different different from the conventional system, and why they require special treatment. So that we are going to look at right now. So one of the key requirement of this data intensive system is the scalability. Scalability is different from the scale, scaling or capacity. See, your system might be able to handle terabyte of data, but if uh, I change the amount of data to say instead of 1 terabyte, if I change it to 2 terabyte, whether your system is scale with the data load or not. So that is scalability. So scalability is the ability of the system to scale with workload or data load. Another definition of scalability can be looked at from system point of view. Say initially you have 10 machines. It's a distributed parallel system, so you have 10 commodity hardware, and you are doing some task in say 1 day time. If I increase the number of machines from 10 to 20, uh, will it still do the same work in half-day time? That should be linearly scalable system, but generally that does not happen. What happens is when you increase the number of machines in any parallel or distributed system, there's an additional overhead for managing these resources. So this resource management also takes away some resource consumption. And scalability is generally not linear. So whatever system which we are going to have for our large amount of data processing for IoT or any other use case, it need to have scalability. Then fault tolerance. Fault tolerance also becomes critical because generally for these big data distributed systems, we do not use uh, specialized hardware. We use commodity hardware. Let's understand why commodity hardware are preferable for creating a data center as opposed to specialized hardware. So in uh, as you might have experienced uh, that a general hard disk of your system crashes or creates some issue on an average once in a 3 year time. So if one hard disk on an average crashes or fails uh, once in 3 years, and if I have thousands of hard disks, and I will have one hard disk failure almost every day. And when we talk about large data centers like Google, Facebook, Amazon data centers, they will have millions of commodity hard disks, and thousands of hard disks might be failing every day. So even during our talk in last uh, 1 hour, Google, Amazon, Microsoft, Facebook, they must have replaced few thousands of hard disks in their data centers. So since we are using commodity hardware, the reason is cost. Specialized hardware are costly and they require also special skill set, whereas commodity hardware are easy to maintain and also cheaper. So uh, since we are having commodity hardware and they have higher probability of failing, so we need to have a system layer which provides fault tolerance. So it can handle the failures at hardware level as well as software level also. Then it should also have higher availability. Even some part of system or network fails, ideally we would expect that the system will do the intended task, at least the compulsory intended task as it is. Or it may gracefully degrade the quality of services, not abruptly hang and stop the services. Then we have heterogeneity. So as we are using commodity hardware, and commodity hardware uh, can be from different vendors. So we should not have dependency on a particular vendor or vendor lock. Otherwise, it will be vendor lock, and in case of emergency, you may not be able to find replaceable items. So that's why it should support heterogeneity. Then load balancing. As you as we saw in the Hadoop, there were multiple worker nodes, data nodes. So it should not happen that a particular data node is, you know, uh, over occupied, over consumed, whereas other uh, worker nodes are not that utilized. So load should get equally distributed among multiple worker nodes. Then modularity. So modularity is the feature. Modularity is the feature where we say that even whatever system we are building, it should be modular so that it gives us ease of maintenance, and it's also extendable and flexible. So we can replace or upgrade particular modules as and when required. So all these big data systems should exhibit all these properties. So when we are creating a new software for that can compete in market for big data analytics and processing, we should focus on all these features. And believe me, all these features are not easy to maintain. It's quite expensive operationally. So let's look at the current status of these systems. So uh, as you can see, so it's a survey till 2020. Till 2020, you can. So we have listed here 14 software lists. So these uh, out of 14, you can see 7 are in the category of data processing, and other 7 are in the category of data analytics. So data processing generally process the raw data, make it useful, consumable, so that we can run various analytics, machine learning on top of the data. And when data is being generated in high speed, we tend to store data at first, and then we look for this process analytics part. So this is the time span. So we covered the survey from 2001 to 2020, and as you can see, the color coding scheme. Green color framework shows the deep learning frameworks, or you can say data analytical frameworks, and yellow color shows the data processing frameworks, and then uh, Oval shape shows the initial release, and rectangular, rounded rectangular shows the uh, latest release. And as you can see, we have mostly picked up the system for which the latest release was in 2020. So we'll take this framework, analyze them further, uh, analyze further, uh, and see uh, what kind of uh, what kind of tactics they are using right now currently to support the big data analytics. So now from this point, the talk is going to be more technical, and we'll look at the what tactics they are using. So let's cover all this one by one. So scalability. So like I define what do we mean by scalability? It's the ability to scale with the workload. So either you gracefully degrade the quality of service, or you you don't degrade your quality of service, but as you have more resources with you, so you scale it uh, scale it well. So there are two tactics using which you can scale. So you can scale either vertically or horizontally. So vertical scaling, we in vertical scaling we uh, we scale by adding more resources by adding more resources. So say you have single system with 16 GB RAM and multiple processors, say i5, and there's a more workload. So now what you do is you increase the RAM from 16 to 32 GB, and you increase the i5 to i7. So that's what we will say the vertical scaling of the system. And in contrast, we have horizontal scaling. So in horizontal scaling, uh, if we want to scale our system capability, we scale, and we scale by adding more system. Addition have there's a limitation in the vertical scaling, that you can add up to certain extent of resources, like you can achieve say 128 GB RAM or 256 GB RAM. Whereas in horizontal scaling, you have much more scalable system. So it can be easily scaled to the kind of data centers we are having currently in Facebook, Google, and Amazon kind of companies. Okay. So another is in vertical scaling, you can achieve uh, ideal scalability because there's not much overhead of parallelism. So it's a linearly scalable systems. And in horizontal scaling, there's a Amdahl law which is applicable, which allows you to see whether your system can linearly scale or not. So Amdahl law talks about the distributedness of the system and how it will scale, or it will induce the management overhead with horizontal scaling. So there are two ways in which we can achieve the scaling. Another is we can use master slave architecture. So in master slave architecture, uh, we we have one master node and multiple slave nodes, like we have seen in the uh, Apache Hadoop software architecture. There were multiple worker nodes, and we have one manager which takes care of all the multiple worker nodes. If one worker node fails, so the manager is responsible to identify the other worker node who will take care of the remaining task, and also transferring the task from one worker node to another worker node. So it's like similar to uh, switching between processes in single operating system. So there are various mechanisms in which we can balance the worker nodes, but we need to have one manager which takes care of it. Then we have concept of parameter server. So in parameter server, we have different processes which are parameterized. And parameterized server means that these servers executes the particular process, but these processes are actually customized to meet the uh, contextual requirement. So as you can see in the TensorFlow architecture, which uses parameter servers, here in this parameter server concept, they are training the different subgraphs in different workers. So each worker process is trained to do different things, and all this context is defined using the parameters to the server. So PS process stands for parameter server process, and you can see each server is customized to give the contextual result in this case. Then there's a concept of data parallelism and model parallelism. Both achieves the similar thing but in different way. So in data parallelism, as you can see in the uh, left side figure, the blue colored figure, data is being parallelized. So data is partitioned, and all the data, all the partitions of the data is going to the different through the same model essentially. And at the later stage, we are combining the learning of all uh, these models output and passing it. So parameter server is another abstraction level concept. At the back end for parameter servers, you can either use data parallelism or you can also use model parallelism, or you can also use combination of these two. So in data parallelism, as we can see, uh, we have divided the data. So data is becoming parallel now. Now to perform such kind of computations, your data should be uh, uh, your data should be such that even if it is partitioned, it gives you the enough information. So it should give you the enough information. And in the model parallelism, we are not partitioning the data, but we are partitioning the model itself. So some part of analytics is happening at model 1, other part of analytics is happening at model 2, and so on. So model is splitted. So different models are running in parallel on the same data. Whereas in the previous case, in the data parallelism, same model was running on the different parts of the data. Now, it depends on the kind of computation uh, computation requirement. Say you want to compute average, you can divide the data, and for each partition of the data, you can compute the average. That is doable. But if you want to compute the mode, you cannot do this computation on the partition data. You need to have all data together in one go. So it depends on the nature of the computation, whether data parallelism is suitable or model parallelism is suitable. And then both the paradigms have their own pros and cons. Like in model parallelism, where model is parallel, uh, again the computation nature has to be such a way that your analytics can be divided and then later on merged after independent computations. So if we look at the model parallelism, uh, if data is huge and everybody is accessing the data from the same copy, it can become bottleneck. Whereas in case of data parallelism, you have separate data and you have separate machines having capability of separate data storage also. Whereas in model parallelism, central storage server will also work. Then we have the feature of like uh, fault tolerance. So in fault tolerance, there are various tactics we can apply to achieve the fault tolerance in the system. So it just gave you the overview of various most popular fault tolerance tactics. So the ways we can achieve it, uh, yeah, like redundancy, migration, failure semantics, failure masking, and recovery. So these are the various ways. In redundancy, we have this either we can have hardware redundancy or software redundancy. And we in hardware redundancy also we can have, either dual redundancy or we keep multiple replicas. So the reason we will keep multiple replicas to achieve higher availability. For example, suppose your data is uh, your hardware, your data is stored on two nodes, and one node uh, face some issue and there's a failure, and the second node is alive, and now you are accessing the only second node. Now what happens? You have only one node, and you you have to rely on that second node only. You do not have uh, you do not have any ways to confirm whether the data in the second replica is up to date or not. Whereas if you have three copies of your data, three replicas, and one fails, you still have two copies of data. You can easily verify those two copies together and see whether they are more reliable or not, whether they are same or not. So like it works like majority vote. So majority of the nodes have similar data, that should be the final one. So to handle one failure reliably, you need to have three replicas. If you want to face, if you want to manage two failures simultaneously, you need to have five replicas. So that's where n number of component redundancy is coming into picture in hardware redundancy. In software redundancy, you can have multiple processes or multiple modules running in parallel. And for example, Hadoop does it. So what it do is, suppose if a worker node is is not in good health, so it's working a bit slow. What it will do is it will uh, it will also run the same job on another machine. So now the same part of the job is running on two machines. One, it was already running, but it's running a bit slow. Other, it assigns a new worker node and run this process on that worker node. Now the Hadoop master waits whoever comes first with the response and use that results. So that is completely software level redundancy. So you are running multiple processes in the same process, same task, same job parallelly, and seeing whatever result comes first is good. Google search engine also does the same thing. So whenever you hit enter, your request may go to 5 or 10 searching engines at the back end, and whoever comes first with the result, that result is being shown to you. Then another way to handle the fault in our system is uh, migration. So you migrate the process from damaged machine or non-performing machine to the performing machine. And if you are using containers or virtualization, you can also uh, do VM migration. So there are, of course, you can do live migration on the go, but there are separate issues related to live migration. Then we have failure semantics. So failure semantics deals with the failures based on what kind of uh, impact they have, context they have. So, like, uh, so in the failure semantics like performance and nomination failure, arbitrary and crash failure, based on the individual failure's impact, you can deal uh, with the semantics, you can change the meaning. So you can say performance semantics. If some worker notes are not available, you will degrade the performance gracefully so that the essential services are up and running. You will not run on the full load, full scale, but you will run on the partial load, but provide the essential services. So that's how we can handle the semantics. Then failure masking. You can mask the failure. Means although there's a failure, you just don't care about those failures, but you mask by having additional setup or something. So like hierarchical group masking. So you assume the hierarchical structure. So if any child fails, all the load is transferred to the immediate parent and so on. So that is what hierarchical group masking. So you create a group of children which are under one parent. And if anyone fails or any multiple children fail, still we can handle those failures. We can mask those failures. Then we have recovery. So recovery is necessary whenever there's a failure to reduce the impact of failure. You would like to bring back the system up and running. So there are various ways like forward error recovery or rollback recovery. And again, there are various ways to perform those recoveries. I'm not going into that detail. Many of you might be familiar with Hamming code or checkpointing concepts. Then we have replication. In replication also, we have multiple strategies to deal with the failures. So in the replication, like in the Hadoop, on the left hand side, you can see a file. Uh, a file is divided uh, between different chunks X, Y, G, and these chunks are replicated across different data nodes. So, like you can see, the X chunk is replicated on data node 2 and data node 4. Y is replicated on data node 2 and 3 and so on. Now, in this arrangement, if you take out any data node, still you will have two replicas of all the chunks working with you. So in Hadoop, a file is splitted into multiple chunks. Each chunk is stored in such a way across multiple data nodes such that you don't lose any data even there's a multiple data node failures, or you lose minimum amount of data in case of failures. So that is Hadoop's strategy. In Kafka, you have different way to deal with this replication. So you have um, one broker and you have two followers. So those follower brokers are also having same partition of the data. but the leader partition is being consumed by consumers and dealt by producers of that data. In case of leader fails, then one of the follower comes and takes the space of leader. Meanwhile, we repair the leader and put it in place of follower. The roles among leaders and followers can be exchangeable, or it may not be true. You can also, bring the follower back to the follower position whenever leader comes back. So both the strategies are fine. Then we have checkpointing in Apache Samja. So checkpointing essentially says that whatever process and state you are currently in, you take care of uh, you take care of this task and process migration. So you keep checkpointing. Checkpointing means what? You are taking those tasks and process state to reliable storage. They are not only in main memory, but they are in storage space. And whenever there is a failure, you pick the checkpoint. So checkpoint allows you to start your halfly done processes from where they were checkpoint. So at the time of failure, you lose only the portion which was done after the checkpointing. So checkpointing is like workaround to reduce the impact of failure. So if your task is running for 1 day, you may, uh, you know, you may tend to reduce the timing of these complete and the checkpointing to every 1 hour. So even if you lose any data, say the system fails at 11:50, so we'll only lose the data of last 50 minutes, not till 11 o'clock. So that is the idea behind checkpointing. Then we have resilient distributed data set. And in my opinion, this is the most important strategy we can see. And the advantage is uh, it has uses of RDD has led the performance gain in Apache Spark up to 30x, 40x, and even in some context 100x as compared to Hadoop. So let's spend some time on how what is RDD and how does it do. So RDD stands for Resilient Distributed Data Set. So resilient to what? Resilient to fault. And how will become resilient to fault? We'll have multiple replica of our data set. So resilient, like you can see the center of the figure, dark green, we have multiple replica of your data sets. So that's what we are calling RDD. Then it's a distributed. We have seen in the Hadoop case, the file XYG was distributed among multiple nodes. In the same way, the single RDD is also uh, consists of multiple data sets. So it's a distributed data set. It's not stored on a single machine. It's stored on different machines. And then it's a data set. It's a logical data set. So if you read one RDD, means you are reading one data set, which is stored in a distributed fashion and that too in multiple replicas to provide the resilience fault tolerance. So we create RDD using files, parallelize them, transform them so that they become the resilient distributed data set, and store them in persistent storage. So we'll see Apache Spark, how it allows you to create RDD. And on these RDDs, you need to perform some action on these RDDs. Action means you can perform some operations. And these RDDs, you build one upon top of another. So say, we'll also understand it by example in the next slide. Suppose you created one RDD, you perform some task on it, some operations on it, and whatever the result is, you have created another RDD of the resultant. Now on this result one, you performed another set of operations and created another RDD with result 2. Now this result 2 is derived from result 1 and result 1 is derived from the original RDD. So this is the lineage. So if I want to recompute result 2 for some reason, I know I need to go to RDD 1 and then RDD. So if RDD 1 is also not available, then only I will go to RDD, original RDD. If results 1 are available, I will go and recompute by only doing the set of operations on result 1. And this result 1, result 2, and result 3, you can assume they are intermediate results. So this is an example of RDD lineage. So let's read this program first. So we are creating two RDDs, R0, 0 and 0, 1. And now we are using a Spark context sc dot parallelize, and we are passing the filter criteria. So we have divided our data into two RDDs. One is 0, 0 and another is 0, 1. Now what we are doing is we are taking the Cartesian product of previous two RDDs 0, 0 and 0, 1 and creating the new RDD R10. We are creating another RDD on the 0, 0 using map function. We are creating the fourth RDD by zipping the R00 with 0, 1 key. And we are creating another RDD by dividing by 20. And then we are creating another RDD by combining the intermediate computations like R1 and 1, 1, 2 and 1, 3. So this is the graph. You can see the computational graph. So this is also showing, directed acyclic graph of these RDDs and their transformation. So R00 is the base RDD for R10, 11 and 12. And these three RDDs are derived from R00. You can say either way. Similarly, you have R20, which depends on the previous 4, and those 4 actually depends on the previous 2. So now you can see how RDD is forming a lineage. Now, suppose if R20 is lost, using this lineage, I can see R20 was depending on the previous 4 RDDs. I'll just query these RDDs. And if something is missing, I go back and see what is the base RDD for the missing RDD. and recompute. So we only recompute any RDD when it's essentially required. And this is also showing some example how the RDD are related to each other. So you can see stage one, A, you do some operations, transformations, you reach to uh, the another RDD B. In a stage two, you divide your C RDD. You perform operation and you come up with D. Now you operate on D and E and create F. So you can see this is directed a cyclic graph of multiple RDDs. And if you see in this diagram, if F fails, you know from where we can recompute the F. Even if G fails, it only requires B and F. So you can safely discard A, C, D, E RDDs from the main memory. So you can free up your main memory if you are sure that B is correct. So this is last uh, tactic. So we can use job agents like in JVM. We use JVM is Java Virtual Machine, and it's also a concept being used by RapidMiner. So you can use uh, job agents for scalability. You can have multiple job agents. These agents can also further handle multiple processes and different worker nodes. And to manage all the jobs, you can have a job container. And then the, for fault tolerance purpose, you maintain the virtual machine of each process running in, or you can also use containers or different persistent storage for fault tolerance purpose. We have discussed a lot about fault tolerance already in the previous slide. So this lead to see what are the open issues are there. So event stream ingestion, like there's an event happening and it's creating a large amount of data. Now data creation might be happening from different sources, but generally it's a requirement to have data at one place. So that lead to event stream related complications. Then data retention, uh, data is becoming highly voluminous and it's hard to really being managed with data. Then distributed learning, uh, it so with this privacy aware AI modeling, people are moving towards distributed learning, where uh, one model is running on different data at the customer machine only. So data is not leaving the premises and um, not going out of the owner's uh, premises. Then data privacy issues. Uh, it depends. Like in some applications, data is quite critical, like mainly health applications. So you need to have a secured and privacy-aware data processing pipeline. Then interoperability. Interoperability talks about how two systems or modules or services are interoperable. Then scalability, like I mentioned, dynamic scalability, in true sense, horizontal scalability is not easy to achieve right now also. Then we have fault tolerance. There are many open issues with different replica copies and different journal level copies. So, mm, given all this information which we just discussed, we can conclude that the current techniques achieves scalability and fault tolerance, but there's a lot more requirement of robustness for sustainability or high reliability, and of course we need to work on our availability and uh, maintain the scalability of the system at the same time. So with that, I'll just conclude my talk. So these are the few references which uh, we have studied to prepare the slides. Okay. So any question, any doubt?
Thank you very much, sir. It was an spectacular session by you. It was pleasure listening to you. Thank you very much. Now, if audience are having any queries, they may please ask. Anyone, any doubt, any query which you want sir to solve it. Okay, sir. I think no one is having any doubt. So we can
Sure.
now conclude this session.
Yeah.
Okay, sir.
Thank
Thank you very much, sir.
you. Thank you, Dr. Viva, for your kind introduction and for inviting me here.
Yes, sir.
Thank you.
Thank you very much, sir, for spending time for this session. Okay, dear participants, by this day 3 session 1 is ended now, and we will be meeting at 12 o'clock for our another session, and that session will be on the hands-on experience using the Raspberry Pi as well as Python. Dr. Rita Jan will be taking that session, so we will again join at 12 o'clock. Thank you very much. Good afternoon, everyone. After the commanding opening of this session, the next distinguished to honor us with her presence is Dr. Rita Jan. Dr. Rita Jan is technopreneur, IoT consultant, and she is having 32 plus years of experience of working in industry and academics. Her engineering education in electronics started in the year 1987 at the Government Engineering College, Ujjain. In 1997, she earned her master's degree in digital communication from MSCT Bhopal in 2012, and in 2012, she added one more feather to her cap, that is PhD in VLSI design and embedded system from NIT Bhopal. Dr. Rita has a lot of related experience that helps her with her current position. She has started her career with JK Synthetics Limited, Jhalawar, as a trainee group member. Then she switched to Optel Telecommunication Limited as R&D executive engineer. In 2003, she switched to academics and served as an HOD in reputed engineering institution. In 2018, she joined Center of Innovation in Internet of Things as Director IoT at Workspace City. Then she started her own startup, AVRN Intelitech for IoT. She is a designer as well as developer of automation and IoT enabled products and imparts training and consultancy in automation and IoT to industry. I would like to welcome Dr. Rita Jan to add beauty in this session and to add her expertise. Welcome, ma'am.
Welcome, ma'am.
Right. Thank you, Viva ma'am. Thank you, Vikas sir. Very good afternoon to one and all present in this particular session. So, if you
Ma'am,
permit,
just a minute, ma'am.
yeah,
I have to introduce the another speaker also.
yeah, definitely, yeah.
Yes, ma'am. In this session, we have another expert, Vineet Jaruhar. Vineet Jaruhar is software architect at AVRN Intelitech Private Limited, Bhopal. He is a computer science graduate and started his career while he was in college as an Android and web developer. This was the turning point in his life. He worked with Hudel Labs as a MLDL intern and contributed to ongoing projects on chatbots, natural language processing, APIs to connect the model to web, etc. Later, he joined Appointee Private Limited as a product development intern and Value Labs, Hyderabad as a software developer intern. Today, he is full stack developer and developed a chat app for government of Sikkim. 10 plus he has developed 10 plus softwares and over 25 IoT products. Today, he is a proud entrepreneur and co-founder of AVRN Intelitech Private Limited. So, welcome, sir. Okay, over to you, ma'am.
Thank you, Vibha ma'am. Thank you.
Thank you, ma'am.
Okay, let me know when my screen starts sharing.
Your screen is visible, ma'am.
Yeah, okay.
Yeah, it is visible.
So after a warm welcome from Vibha ma'am, let us see how the lectures goes on. Today, the topic of our discussion is something related to practical lab session rather. Moreover, we will be covering some theory on the Raspberry Pi. And basically, Vinit will be giving you an insight on the language that is the Python, which is commonly used for the developments which are done on Raspberry. So coming back, recently.
Excuse me, ma'am. Sorry to interrupt you, but
Yeah,
if you
ma'am.
can open your camera also.
Yeah, sure, ma'am.
Yes, ma'am.
So let me share something which wonderfully happened on 29th of January 2022 at Vijay Chowk. A fleet of 1,000 drones, they made beautiful sculptures into the air and it was appreciated like anything. And this was the first attempt done by new startup that is the Boot Lab. They were supported by Indian Institute of Technology Delhi as well as Department of Science and Technology Delhi. So this is one of the things which gives motivation to the students how the technology goes on and what should be done to come up to this particular level. And the story, today's story is related to all these things itself. So I'm just putting some of the clips from 29th January. These were the structures which were made by almost all 1,000 drones, wonderfully portrayed into the sky, and still lot of things has to be done further in this particular field. So drone is one of the emerging area, as we all know. Since the topic is IoT, so a lot many things goes into IoT. It starts from a scratch, maybe just switching on an LED and it goes up to the drone. And I can say the sky is also not the limit for this particular technology. I just want to share one clip how the students are motivated and happy when they develop something like this. Right. So this clip we have taken from Intel, as you have all seen, and I just wanted to show you the motivation, the joy which comes onto the faces of the developers and the designers of the such kind of technology when it is being used in the by the public for the natural use and for their use itself. So this is one of the good example. Coming back to Internet of Things, I don't know how you people take it, but a lot many things strike to my mind when we talk about Internet of Things. Internet of Things, first of all, as people say that, okay, a cup of coffee will be ready whenever I talk to my coffee machine, or it can be something like a smart refrigerator if I am having at my home. So it will automatically tell me what is uh, which particular bin is empty, or what is having a particular shelf life when it should be refurnished, and so on. But when it comes to technology, it is not that easy as we talk in terms like kitna bharna hai, kitna khali hai, something like that. But a lot many things goes into Internet of Things. All of the things cannot be done at the same time, and that is why always a team is required to work on this particular technology. When it comes to Internet of Things, I will say Internet of Things is not only one technology. It is a mixture of lot many technologies which has been immersed in the last, say, 5 years and so. So coming back, general definition, what is Internet of Things? Yes, Internet of Things is a network of smart devices that connect and communicate via the internet. So this is one of the simplest definition which we can have for Internet of Things. When it comes to smart devices, what is the meaning of a smart devices? As we all know, we all are a smart, and anything which can be done smartly will come into the category of a smart device. When it comes to a device, in case of Internet of Things, it is known as thing. And this particular thing can be any physical object. It can be a passive device or it can be an active device. Even it can be a human being, it can be an animal, and so on. So when it comes to Internet of Things, that means only two particular words come into my mind. One is the internet, another is the things which come up. So internet, we all know that it's a use network, and not a single corner in this globe is deprived of internet activity. Whenever you feel like talking to someone else, whenever you feel like surfing something, the internet is the first thing which comes into our mind. And we have a very good device in our hands, that is the mobile. And this mobile, if it is connected to internet, it gives you a wonderful experience of using the things. The second is the thing, that is the part from the electronics. As we all are from the electronics background, I will like to connect it to the systems. Like things can be any kind of a sensor. Even if I have to make a particular thing a smart thing, I have to connect a sensor to it. When I connect a sensor to it, then I need to collect the data from the sensor, and I should place it somewhere where it can be beautifully used. Maybe some processing can be done, and so on. So to make a particular thing a smart thing, just put a sensor, give up it IP address that is connected to a network, connected to an intelligent device. So the data, whatever is available from this intelligent device, can be further processed and can be used. So this is in simple words, I can say how the electronics is related to Internet of Things, because lot many people say no, it is belonging to the computer science area, but no, the core area in this Internet of Things is always the electronics. So basically there are four major components in case of IoT. The four components, I will say, it is sensors. They are basically used to collect the data. We have a connectivity, that is sending the data to the cloud. Instead of cloud, it can be any kind of a server also. like the cloud itself. Then we have a unit which is used for data processing, that is making the data useful, because whatever data is collected, it may not be used for regular durations. It may have some other impact also. And last one is the user interface, how the user need the data, what amount of data is required, what is the importance of data to a particular user, because same data may not be used by the two different user or more than two different user in the same manner. So depending upon the utility, the data can be processed and it can be supplied to the users. Coming back to the architecture of the IoT, ITUT has already approved a 7-layer architecture. But for our knowledge and for working, I am coming just up to the 4-layer in case of IoT. The first layer is known as the perception layer, in which we are connecting all the smart devices and the controllers, you can say. Next layer is the transport layer, which gives the connectivity from the device, a smart device, to maybe a server or a cloud. Third one is the processing layer, in which all different type of processing takes place. That is, the device management can be done, data management can be done, analytics can be applied, edge computing can happen, and so on. And last one is the user interface. In whichever manner the user needs the data, it can be provided to them. So this is the simple architecture. Today's topic is going to lie in the perception layer and maybe somewhat in the transport layer and the processing layer. We will try to mix them up just to share the basic knowledge, not more than that. So what was the idea behind Raspberry Pi? We have seen foul faces of our students. There are a lot many students, those who want to learn computer. By learning computer, they want to do different type of programming, but they are unable to do at times. There are certain difficulties in their face also, like they don't have much idea on the CPU, or they don't have any practical programming knowledge as such, but still they want to take up the things as they are coming up. So at times also we have seen, like if we go for a purchase of a computer in the market, sometimes our pockets are not allowing us for a kit to use such kind of systems at home, because we know whenever a toy is given to a kid, what is the first experiment they do? They just break open the toy, try to learn whatever is there inside, and then they ask for a different toy so that they can again come up with their different curiosities. So that cannot be done with a computer or a laptop or the heavy mobiles which we are using these days. But still something should be done, and that is why the idea of Raspberry Pi has come into the picture. So basically, Raspberry Pi is promoted by Raspberry Pi Foundation. It's an educational charity or NGO, you can say. Way back somewhere in 2006, when Eben Apron was in Cambridge University, he came to know that almost all the applications for computer science branch was 6,000. But by and by, when the allocation came, the students just quit that particular course, and hardly 250 people were there to join this. So he just started like, what is the reason why the people or the students are not joining this particular course? Then he found out that there are so many reasons behind it, like they are unable to afford the costly items, they are unable to go with the programming because this particular device is not available with them throughout the day, and only the lab facilities are not sufficient to learn such kind of things. So that is why he started this particular work of developing the Raspberry Pi. And their team particularly started in 2006, and by 2012 something like Raspberry Pi should be said has come up. So almost all 6 years it took, and Broadcom was one of the company which supported them like anything. They gave the chips, the programming languages, and so on. So what was the need for Raspberry Pi? The basic need for the Raspberry Pi was whatever fear was there in the students. So taking IT back to the basic and making it accessible to each and every school. This was the basic idea. Like the knowledge of the programming should be given to the student, not at the college level, but it should come from the school level itself. Today we know whenever a kid of 1 year he is handling a mobile, they handle the mobile much better than us because they know which particular feature will work how and where to find that particular feature. So if we inculcate this habit of programming at the school level itself, then we will be having masters at the age of say 20, 22 and so on. So to see the Raspberry Pi begin used by the kids to all over the world to learn the program. So it was a bi-directional thing. Inculcate the habit of programming at the level of the school and get a master or a maturity person or a developer at the age of say 16 and so on. So this is basically what the idea was there for Raspberry Pi. If you come to the characteristics or the qualities or features, you can say for the Raspberry Pi, it's a very small device. It is almost all maybe a size of a credit card when it is started, but now definitely today it is somewhat bigger than a credit card, but the capabilities of this particular device is very good. So I can say whatever you think you can do with a computer, a normal computer can always be done with the help of a Raspberry Pi. And the idea was that it should be a cheap device. It should not be very expensive. The parents should not hesitate in purchasing it. That was the thing. So it is very cheap in their language. I will say it is hardly $25 to $35 per piece. And if I come to India, definitely the lower versions you can get in hundreds, 400, 500 rupees. But when you go for the higher versions like Raspberry Pi 3, 4, and so on, yes, they are costly. They are starting from rupees 3,000, goes up to 10,000, 8,000 to 10,000 each. Right, so this is all about Raspberry Pi costing. Coming to the capability, I told you whatever you can think of, each and everything can be performed by Raspberry Pi. So it can be music machines, detectors for the weather stations. It is quite capable of browsing the internet and playing the HD videos and so on. We can even make a spreadsheets, words processing. We can think of playing games because for students, it is always playing games, and through games only they are developing their habits, different type of habits. It may be programming a skill or it may be developing some new concept or algorithm. Raspberry Pi is very versed with the infrared cameras, the security systems. It can work with lot many electronic systems. It has the processing power. It has a very fast speed of working also. So why the name Raspberry Pi? As we all know, in those days, whenever a computer company comes up, it came up with the name of a fruit. Maybe Apple, maybe BlackBerry, Tangerine computer system, Apricot computers, Acron computers, and so on. And that is why the Raspberry came into picture. But why Pi? The reason behind the Pi is that Python interpreter or the Python language was supposed to be used with this Raspberry, and that is why putting both together Raspberry Pi. So in simple words, I can say the Pi is a part of Raspberry itself. So coming to the hardware is in general whatever you can see into the computer. We are having a CPU, we are having program memory, the peripherals are there, video is there, GPIO, that is general purpose IO ports are available, GPU is also there, SD card is there. This particular module, Raspberry Pi, is not available with a hard disk. There are a lot many things which are not available. As a peripheral, we have to attach them externally. So all the models of Raspberry Pi, they are equipped with a Broadcom system chip. It is having a CPU as well as the GPU that is quite capable of Video Core 4. And the speed of the CPU, it varies along with the model. The speed has been from 700 megahertz to maybe 1.2 gigahertz, I can say. The onboard memory is also depending upon the versions and the modules which we are using. It varies from 256 MB to something about 1 gigabyte, I can say. Instead of hard disk, the modules are equipped with the this thing SD cards, that is the secure digital cards. So instead of having a bulky hard disk, this SD card is a very simple chip. It can be attached directly to any of the system. Any type of program can be inbuilt into it, and we can boot the Raspberry Pi along with the operating system of the Raspberry Pi. So most of the boards will be having all these things like a CPU, GPU is the must that we have already seen, but there may be some lacuna in case of peripherals for the small devices, but how the things can be incorporated into it, that we will see. It is also equipped with a Wi-Fi as well as Bluetooth for external connectivity. The Ethernet port is also a must in case of Raspberry hardware. So let us have a look at one of the modules. This is Raspberry Pi model B, which we are having. So you can just see the different type of components which is present on this thing. There are 4 USB ports. There is one Ethernet port. We are having one stereo audio port, that is 3.5. Then we are having a CSI camera port where we can incorporate or interface any camera. Officially, it is acceptable that Raspberry Pi components must be used, but different type of components, cameras are used in this case. Then Raspberry Pi 4 is having dual HDMI port. That means 2 displays can be connected to this Raspberry Pi. Then it is having an USB 3.0 power port also. That means you can just see how the components have shrunk from a big CPU to a small Raspberry Pi. So all mini and micro components have been used. Then it has a micro SD card slot that is on the other side of the port. Then we have Wi-Fi as well as Bluetooth and so on. So these are the major components which are going on the Pi 4 model. If we check in comparison to Pi 3 model, some of the things have been slashed down. Like instead of having 2 display boards over in Raspberry Pi 4, here we are having only one port. Only one port or one display can be connected to Raspberry Pi Model 3. Rest of the things remains the same. We are having a micro USB power unit. Then we are having a CSI camera interface. We are having 4 USB port for external connections. Ethernet is also there. Then the power of this particular device is in the 40-pin header. Now this 40-pin header is not necessary. It is available in all the modules depending upon the versions, but definitely I will say that in Model 3 and Model 4, this 40-pin header is available. Maybe the pin configurations can be different. They can be different GPIOs allotted for the same functionality, but more or less whatever is available in 40 pins at this particular point in Model 3 is also available in Model 4 also. Coming back, what is the difference between the 2 models? The difference is going to be in terms of speed. It is going to be in terms of videos and the other features which goes into it. When it comes to power supply, definitely it's a very small device, but its power consumption is very high because it's a very powerful device. If you see here, micro USB power in, they've already given the figure of 2.5. This particular power is consumed only by this particular board. If you are using additional peripheral ports with this particular device, you have to increase the power of this thing. So we have seen in lot many cases, minimum 5 to 6 ampere power is consumed by a Raspberry Pi port with full-fledged peripherals coming into the picture. So if we go with the historical journey, as I've already given that 2012 was the first Raspberry Pi board which came into the picture. Since then, they have come up with different models with different features and so on. And you can see that with every model, you will be find different modules like A, B, A plus, B plus. Basically, B and B plus, I will say that B plus is the full version of that particular Raspberry Pi. Whereas A and A plus, they are the lower versions. They are not fully equipped for all the peripherals. That is the major difference. The other difference is definitely the speed and the features as I have already given you. So the latest version, Raspberry Pi 4, is being used for lot many projects, but the developers prefer to go with Raspberry Pi 3 Plus. Okay, so coming back to the CPU, BCM 2835 chip is being used, as we all are from the electronics, so we must be concerned about the architecture. It is basically using ARM V6. It's a single core chip, 32-bit RISC processor is there. Its operating clock frequency was 700 megahertz. It has lot many pipeline stages. In this case, it is 8, and a branch prediction technology is also being used. So basically, all the Broadcom chips, they belong to the ARM family. Right. So some of the chips which are regularly used with the Raspberry Pi are BCM2835, BCM2836, BCM2837, and so on. The entire architecture depends upon the type of features which we are feeding into it. So the latest version and the smallest version of Raspberry Pi which is into picture is Raspberry Pi Pico. That is definitely a credit card size module, and it is using RPI 3A0 and the extension is 117. That is the version which we are using in case of Pico. Right. So whenever we have to set up a Raspberry Pi for use, we need to add some hardware to it. The very first one is the monitor, or you can even use a television. Again, reminding you what was the purpose of the Raspberry Pi. The purpose of Raspberry Pi was to inculcate the habit of programming in a student. When it comes to student, whatever things can be easily handled by the student and available at home, those things were kept into mind before designing the ports. So television sets are very common. They are available at almost all at all homes. Keyboard and a mouse is required. You will be needing a USB hub if we are using A or A plus model for it. Then instead of hard disk, I've already told you that SD or a micro SD card is used, so that will be required. Definitely to connect the monitors, you will be needing HDMI cables. These can be in a variety depending upon the model. It can be a simple HDMI, it can be a micro, even it can be a mini also. Then you will be having a power supply, again an adapter that is 230 to 5 volts simply with a mini or a micro HDMI port for it. So these are some of the essential components which will be required whenever we are going for setting up of a Raspberry Pi module. There are other requirements. As of now, it is not necessary that they must be present. So these are preferable and those were the desirable. So we can have a Raspberry Pi case, there can be speaker, the heatsink, definitely the software which we want to use, Raspberry Pi camera module, Wi-Fi adapter has to be there. External hard drive can also be used along with different type of cables, I will say. We may be needing certain type of cables to connect the old monitors to your module, or it can be a television set. We can have a different type of, say, a camera which can be connected. So depending upon the module which we are having, we have to arrange the peripherals accordingly. Then to support this particular device, we are having add-on cards also. So we are having a sense card, a wonderful card, such type of cards which are increasing the feature of the Raspberry Pi. They are also known by the name of hats. Like in case of Arduino, we call them as shields. So here it is hat, that is hardware attached on the top. So Sense is a wonderful card. It is having lot many sensors onto it. The beauty of hats is it directly goes and fit into the 40-pin connector which is available on the Raspberry Pi modules. So we don't have to do any networking kind of a thing, no wires, no jumpers, nothing. Just keep on putting one over the other and keep on adding the functionalities or the features. It is said almost all 92 cards can be added on one Raspberry Pi. Depending upon our requirement, yes, definitely it can be done. So when it comes to SenseHead, it is having a device you can generate a weather station with this particular thing. It is having a gyrometer, it is having an accelerometer also, and it is having a matrix of RGB LEDs. We have seen in case of drones, they were blinking in different colors. So this particular color can be obtained through the RGB LEDs straight away. The other modules which are available is they are for the motor driving, they are for the temperature sensing, they are for the automation activities, and so on. So whatever feature you want to incorporate, a hat will always be available with the Raspberry Pi. So, and the thing is, there are lot many hats depending upon the modules also. It is not always the 40 pin which goes into the criteria. It can be even 26 pins. It can be even with the 10 pins also. So depending upon our requirement, a particular hat can be selected and it can be interfaced straight away. Coming back to the GPIO pins, as I've already given you an indication that there are 40 pins. So when it comes to 40 pins, what are their functionalities? Almost all 8 pins are reserved for the ground connectivity. We are having 4 pins for the power, and rest of the 26 pins, they are having multiple functionalities. They can be used as input ports, they can be used as output ports, and so on. So when it comes to general purpose IO pins, what all activities can be done? We can control and we can monitor any outside world. They can be connected to the electronic circuits. We can connect, say, motor drivers to them. We can have certain switches which can be switched on and off. Even we can connect directly the sensors, maybe a humidity sensor or a temperature sensors, and we can read the inputs. And accordingly, we can give the outputs to the actuators also. This is the main functionalities of the GPIO ports. When it comes to other functionalities which can be incorporated, as I have given you, we can use these pins as multiplex pins like we used to do in case of 8086. Our address and data lines are multiplex. So here also we are having multiplexing in case of pins. That is why everything can be confined in 40 pins. Otherwise, it has to be a higher number of count of pins. So a particular pin can have two type of functionality. Apart from two type, it can have another 6 type of functionalities in that case. That is, an alternate features can have been added in case of GPIO pins. So input and output is the general thing which can be done. They can be pull up, or it can be in the mode of pull down also. Then other functionalities which come up is PWM. We are having then I2C, and so on. So these are some of the features for communication, because we have to communicate with the CPU in case of Raspberry Pi. So coming back, the number of pins I've already given you. For ground, we are having 8 pins. For plus 5 volts, we are having 2 pins. For 3.3 volts, we are having again 2 pins. When it comes to 5.5, what we can also pull power from this particular port for a small application. Like if you have to use 2 or 3 LEDs on your board, then you can have power from this port. Otherwise, when it comes to a series of LEDs, then external power supply is a must. And you will never come to know when the power is required by the board, but you can always understand whenever there is a malfunction in a particular program. That means now we have to add some power to the Raspberry Pi board. Then we are having a SD card interface. Almost all 6 general purpose IOs are available for the SD card interfacing also. You can just see these pins are named at Alt 0 and Alt 3. And coming back, we are having other functions which is known as JTAG, that is Joint Test Action Group is there. It is basically used, they are giving specifications and the methods for debugging the circuits in case of ICs. So whenever we are using an IC, when I say IC, I am just talking in terms of, say, maybe 1,000 or 10,000 gates on a particular chip. So JTAG is the best interface through which it can be tested. Coming back to one more thing, which is known as UART. Yes, UART is the ultimate serial communication interface which we have on the Raspberry Pi. We are having almost all 2 UART with this particular project. So the pins are lot many pins you can see here, they have been allotted. So here you can see the physical, this is the physical pin number. Next to it is the BCM channel number which we are having. And this is the other functionality or the alternate functionality of this particular pin. Generally, whenever we are using a Raspberry Pi, we will be using it either with a pin physically we can address it, or we can address it with the help of a BCM channel also. Okay, so you can see lot many CTS, RTS, TXD is available, RTS is available. Then we are having second channel. So again, you can see there is CTS, there is RDX, there is RTS, and so on. So 2 channels for serial communication has been included in Raspberry Pi. So while setting up this particular thing, that is Raspberry Pi, either 3 or 4, we are having one more functionality which comes into the picture, is known as a headless. Now, what is headless, that we will discuss later. But if we are not having this UART, then headless thing cannot be done very easily. The next functionality which goes with the Raspberry Pi is the PWM, that is pulse width modulation. We know why pulse width modulation is used. It is basically used to drive the motors. This is one method for creating the analog signals, or I can say a toggling a digital pin and so on. So basically, when it comes to lab practicals and so on, we are using it for as a motor driver. So almost all 4 pins are reserved for this particular thing. Then we are having another interface, that is the serial peripheral interface. Again, it's a 4-wire serial bus. It can be used for chip select kind of a thing, and different peripheral chips which will be using in different type of projects. So almost all 4 pins are required, and that is why you can see we are having 2 SPIs in this. Okay. Then coming to I2C, again I2C is I can say a 2-wire communication, a serial communication with a low speed basically, and lot many devices are supporting I2C because the number of wires which are required in this communication is only 2. So instead of going for 6 wires or 8 wires in case of say UART, or it can be your SPI, this is more preferred communication channel in the embedded systems these days. Now, how to check which particular pin is available with the how it is addressed in the this thing Raspberry Pi. So only a one command is required at the terminal, that is pin out. As soon as you type pin out, the this Raspberry Pi, whichever is connected to the board, is going to give you all the pin numbers. Pin numbers are available in both the modes, that is, one is the physical position is identified, and second, the board name or the Broadcom SoC channel name is also given. So each and every pin will be having 2 type of addresses. We can use only one type of address in our programs, or we can go for both the things, but we have to do the addressing accordingly. So there will be changes in the program instead of changing the pin numbers. So just how to address the pins can be, you can just go through this particular slide. First of all, to address a particular pin, or you have to address the 40 pins, we have to include certain libraries. So first module which we have to incorporate is the RPI .GPIO module. Here what is going to happen, it is going to give a very short name to the particular pin. So each and every pin can be addressed as GPIO when we are using this particular module. Then coming to addressing of the physical pin, simple command can be given, that is GPIO.setMode, GPIO.board. Board is the physical board pin which we want to use. So that is the numbers which you have seen 1, 2, 3, 4, and they are in continuation if you see. So these are the board pin numbers, 1, then 3, then 5. This side is the odd number of pins. On this side, we are having the even numbers pin. And these GPIO, these are the BCM channel numbers. So accordingly, we can write them into our program. Then if we want to use the BCM channel, the command is going to be GPIO.setMode. We are just setting the mode as we do in case of Arduino. That is GPIO0.BCM. BCM means you have to use the GPIO ports that can be 1 to 26. Now to set up a particular channel as an input or an output, we have to call either GPIO.setup channel, GPIO.in. That is for the input of a signal into this. Whenever you have to read a particular sensor, then this particular command has to be used. Then coming back to setup for a channel, this is for the GPIO for defining that particular pin as an output pin. So when we have to read an input channel, we can simply say GPIO.input. This is the channel number. Here we have just set the mode where that particular pin is going to act as an input pin or an output pin. Here we are just talking to read that particular value. Similarly, if we want to change the state of a particular device, we are supposed to call GPIO.output bracket mein you can write the channel number and the state. When it comes to state, the states are in digital form. It can be true, false, it can be 0 or 1, it can be yes or no kind of a thing, even true or false. So these are some of the commands which we will be using in our programs regularly to read and to write the things. And at the end of the program, it is always good to write GPIO.clean up, because whatever you have done, it will be cleaned up automatically with this particular command. So when it will be covering it in detail, further detail, I'm just giving you the indications how the things will be done. This is a simple program which we wanted to highlight how a program in case of Raspberry Pi is going to look like. So this is the thing, import GPIO.GPIO0 to use this all the ports. Then you can import some time. You can just define LED 18. So this 18 is the physical number over here. It can be defined accordingly. Switch I have set 31. This 31 cannot be a GPIO, that is BCM channel number, because BCM channel numbers are limited to 26. So accordingly, we can set the modes. We can use the board, that is whatever pin numbers we have given over here, they are the physical pin numbers, and so on. Right. So once we say it's a single the card operating system, so sorry, single card computer, so we need an operating system with this particular system. Lot many operating system go with Raspberry Pi, but the recommended by the foundation is the Raspberry Pi OS, which should be used with the Raspberry, any model of the Raspberry Pi. But apart from them, the different OS which are available are Ubuntu. You have a Snappy, Ubuntu Core, Windows 10, IoT Core is there, OSMC is there, Rusk OS is there. So depending upon the activity and the applications required, we can select a particular OS and we can start working it. The official languages which are promoted by Raspberry Pi is the Python and the Scratch. Scratch is also preferred these days because it is only drag and drop kind of a thing, and it is grasped very easily by the student. So such kind of things are available for the kids to teach them programming. Scratch, again, a very creative tool. It is developed by the MIT Media Lab, and a visual programming language, I can say. I've already given you that it's a drag and drop interface, and lot many things can be done, and lot many examples are also available. When it comes to Raspberry Pi or it comes to Arduino, The community of these two processors is very, very huge. You just think of a project, and the project can be sourced on the internet. You will be finding lot many people, those who have already worked with. You can find lot many blogs where they have discussed the problems which they encountered when they were doing programming for the first time, or when they were integrating the hardware for the first time, and lot many solutions are also given. And that is why these two devices are quite popular when it comes to IoT. Python programming, yes, when it will be covering this particular things, I don't stress on this. So how to set up a Raspberry Pi? There are lot many options through which we can set up. The recommended option is Raspberry Pi Imager. What you can do when the community is too good, that means Raspberry Pi has promoted this thing like anything. And when you go to the official site of the Raspberry Pi, all the instructions are so clear that you just keep on reading the site and you will come to know what has to be done in which particular manner. So first of all, what is required to set up a Raspberry Pi? You have to install this OS into a SD card. This SD card, although people recommend that it can be 8 GB, but these days with the Raspberry Pi 4 module, people say that it should be 16 GB at least, because this SD card will be required for both the things. It will be for the operating systems as well as for the programs which you are incorporating in through the Raspberry Pi into different systems. So the partition has to be done, and accordingly, we should keep on increasing if required the SD card capacity. If 8 is sufficient, you use with 8, and if further is required, you can get it directly connected to 16. But whenever you choose a new SD card, every time you have to burn this OS into it. Okay. So two methods, Raspberry Pi Imager is available, and Noops is also available on the Raspberry Pi site itself. And as I've already given you, the system is quite simple. Just keep on reading, keep on doing the things, and you will get your system, this OS installed into the system. So first thing is download a particular, as soon as you open this thing, I've given you the site Raspberry Pi download page is there. As soon as you open this particular page, you will be coming directly to this page, that is the download. From this download, you have to select which particular OS is required as per your machine. Yes, when it comes, Raspbian was known as, OS was known as Raspbian earlier. Now they've straight away said that it should be called as Raspberry Pi OS. So coming to Raspberry Pi OS, you can go to the setup wizard. The setup wizard will tell you what has to be done next. So you can go for the installation straight away depending upon your machine. You have to select an OS, which type of OS is required depending upon your module. Then you can choose the storage, like whatever SD card you have been used, you will be using to install the OS into it. Different modules will be available depending upon your system. So you can select which SD card has to be used. Once it has been selected, then straight away you can see write to it. Apart from that, it is going to ask you a lot many things like how to access different facilities on the board, which is a Wi-Fi, it can be a Bluetooth, it can be an internet connectivity kind of a thing. So a lot many options are available which can be addressed at the time of the OS itself, or it can be done later on when you connect the Raspberry Pi to different peripherals. So we can configure it at the first instance itself. So what we are going to configure, it is going to configure the host name. It is going to ask you SSH. SSH is a headless connectivity of a Raspberry Pi to your system. It works on a local system only. Then Wi-Fi for the internet connectivity, you can say. So it will keep on asking one by one, and you have to specify the things as it keeps on asking it. So the host name is the Raspberry Pi, works on the local. You can enable the SSH from here itself. keep on moving, you will be getting each and every window, you will be getting the instructions and so on. So here we are just setting up Raspberry Pi. We are enabling the SSH. The passwords and the host names, they are not different. You have to change them. At maximum places, they are using either a Pi or Raspberry as the username as well as the password. Authentications, yes, you have to give it on your own. You have to tell which particular network you have to connect your system to, and you have to give the password of your network itself. So here, if you are having a system modem, say maybe a name is ABC, so SSID is going to be ABC, and whatever password you have given to your modem. So that can be incorporated here. You can just put the country also, that is also required. So here for India, it is going to be IN. So it is a scroll down option. You can always keep on selecting and doing it. Keep on saving the work so that at the end it will be installed perfectly. So this is almost all the last window on the Raspberry Pi. You have already selected operating system, you have selected the storage device, and now you are ready for the installations. So the installation will take few seconds to come up. So once this thing is over, it will ask you, it will prompt you. And once you press continue on this particular window, your SD card can be removed very easily from here, and it can be incorporated on the Raspberry Pi module, whichever we are using it. Okay. So this is the next process, that is the NOOPS. NOOPS is nothing but new out of box software. This was used earlier to copy the operating system from the Windows to a SD card. So this is how the Windows is going to look like. Depending upon, we always prefer to use the NOOPS here. We are not going with the NOOPS Lite. Okay, the same standard process. Before using the SD card, it is always advisable to format it. And the formatting can be done with any of the software which is available with our system, depending Windows you are using or Linux you are using or Mac and so on. So once the formatting has been done, just go with the NOOPS. You can just open the files. You have to copy the NOOPS files into the SD card. They will be extracted first of all into your system itself, and from there it can be very easily copied into the SD card. So this is the old process. So that is why Raspberry Pi has now recommended Raspberry Pi Imager. And it's a very simple system. Once you do it, you will come to know that nothing much is required. It hardly takes 15 to 20 minutes to complete the installation, as well as you can start implementing a particular project also. So the two systems, the Noob and the Raspberry and Image system, the only difference is you have to unzip copy, although it says when it comes to Raspberry Pi Image, there is no installation required at the Raspberry Pi end. The entire installation job has been done at your own machine, that is this particular machine. But when you go with the Noobs, then you have to go for separate installation at the RPI. Okay, so final setup, you can see how to do the things. You have to attach all the peripherals. This one is the SD card. First of all, it is going, then you can connect a mouse and a keyboard. You can even connect an Ethernet port over here. If you need audio, then you can connect an audio. You can connect a camera in this particular slot. You can use this particular port to connect your display. And this is the power thing. Then you have two LEDs over here. One is red, one is green. One is used for the power, another one is used for the activity of the SD card. So these are the indications which are available on the board. And now this board is ready to do any kind of activity as per your program. Okay, so connecting Raspberry Pi to the internet. If you have not done the entire installation by giving the internet or SSID to your system at your own very first machine, Then coming to Raspberry Pi, you have to do this kind of an installation. In case of noobs also, you have to come up with this kind of an activity. The thing is, you have to add extra 2 files to your system. One file is named as wpa_supplicant.config. Certain commands have to be posted into this particular thing. The same thing, that is SSID, you have to tell what is the SSID of your system. You have to give the password, you have to give the country name, and so on. So these few lines are required in this particular file, and it can be given to the root, whatever route you are following for the installation of the OS into the thing. Then comes the second file, that is the SSS file directly. But this particular file is an empty file which can be created into the system, and it doesn't go with any extension. No extension is required for this particular thing. So whenever Raspberry Pi boot for the first time, it will automatically come to know that some headless operation has to be done in this. Okay. Now to communicate with the this Raspberry Pi and the system, you need a communication interface. So the popularly used one is the PuTTY. You can download PuTTY and then you can start operating the system in a headless manner. That means you don't have to attach any kind of a peripheral to your Raspberry Pi. Neither keyboard is required, not mouse is required. You don't need an display system also or a monitor in this if you are using headless configuration. So you can download PuTTY again. PuTTY is also very user friendly. It will keep on popping the things and you have to just go follow the instructions. So as normal software installation, you will be having putty.exe file for the installation. Keep on following the instructions. You have to open PuTTY, you have to give the host name, you have to give the port, you have to give the type of connections, how the Raspberry Pi will be connected. So feed all these things. You can see how the things have been written over here. You just have to select a particular alternative and then you can just start the installation work. Okay. So the main thing in this case is when you are coming up with the last window, instead of saying yes, just say no. Okay. So this is one thing. And once it has done, you can just log in. You can give the password and you will directly come to the terminal window of your system. You can just start coding at this particular place. You can run different type of programs. You can see the result on the Raspberry Pi board. And when you have to exit this particular thing, just write a single command, that is pi at Raspberry, and it will be, sorry, sudo power off. So it will just come out of this terminal window. So this is how you can install the system into a Raspberry Pi. If you are not using headless, then what is going to happen? You will be connecting a keyboard, you will be connecting a mouse and a monitor to this. So this is the first window of the monitor, window of the Raspberry Pi on the monitor. It's a beautiful thing to see. From here, you can start with different activities. Like if it is not headless, then you have to give the different type of passwords. You will have to incorporate or install the internet into it. So there will be different windows. Like this is the very first window, that is the welcome wizard you will be having. Again, it will ask you what has to be done. You can cancel it. You can go up to the next. You can even install Bluetooth into it. Then it is going to ask you different activities like the country code, the language in which you want to use, the time zone setting will be there. Then host ID, the password, your Wi-Fi, whether the update is required in a software or not. So all these things will be prompted and you can just keep on selecting and giving the instructions to the Raspberry how it has to act. And this is going to be the final window. You will be coming up with these 4 icons on the top left corner of the monitor. This is Raspbian, through which you will be doing the entire thing. This is the Chromium. where you can browse your internet. Then you are having a file managers where you can see what are the files stored on the system. And this is the terminal mode. If you want to operate it, you can just directly click and you can go to a terminal window. So this is where we are going to start the, we can always start the programming. So once you open the Raspbian icon, these are the other menus which are available: programming, internet, sound, video, graphic. If you want to change something in the sound or video, you can just click this particular thing. If you want to change the setting of the internet, you can go to this particular menu. When it comes to accessories, so many things are available. You are having a PDF viewer, you are having a calculator, then you are having a SD card copier, task manager, terminal windows, and so on. A good amount of help is also required. This is where we can start programming languages. So I think I will hand over now to Vinit so that he can start with the Python. Vinit, are you there?
Welcome, Vinit sir.
Thank you, ma'am. Yeah. So I'll start sharing my screen.
Yeah.
I'm unable to share my screen. It says that host has disabled.
Sir, just we are making you host. You have entered with the name of Vinit Jaruhar only?
Yeah.
Yeah, we'll check. Okay, sir, we have made you co-host. Now you can start sharing.
Okay. Is my screen being shared?
Yeah, Vinit, it's shared.
Yes, yes, it is visible. You can set it in slideshow mode.
Yeah. Thank you, everyone, and good afternoon. I'll be covering the coding part and we'll continuing the session, the wonderful session which ma'am gave. So these are the things which we will be covering. So coming to Python, Python is a very popular language right now. We all have been using Python in one way or another. It is a high level language with object orientation, dynamic semantics, and it is basically based on high level data structure. So we don't have to go in too deep with very rudimentary data structures like linked list or other data structures which we study in C, C++, or in general programming paradigm. And it is a dynamic type language, which means we don't have to declare the type of the variables whenever we are declaring a variable. So it gives a flexibility in terms of programming. It is also used for rapidly developing any application because the programming is too easy when we are using Python. So coming next to its history and its versions, it was first founded in 1980s by Guido van Rossum in Netherlands. And since then, it has been continuing being updated and improved upon. So in 1994, Python 1.0 was released with features like lambda, map, filter, and reduce. These are some advanced features for array or list which we use. They can iterate over an array faster and perform certain actions for which earlier we used to write certain functions for it. Then Python 2.0 came. It had certain object orientation capabilities like garbage collection and comprehensions. Comprehensions are nothing, just one liners for a multiple sentences. It is a very desired feature of Python. And in 2009, Python 3.0 was released, which we are using till now. And the current version of Python is Python 3.10. So it was released in 4th October 2021, and we are currently using this version only. Now we'll quickly come to the basics of Python. So first we'll learn how to declare a variable in Python. What are variables? Variables are containers which are stored for which are used for storing data values. In Python, generally we don't have any command to declare any variable. Like in languages like C++ or Java, we used to declare the data type before a variable, before declaring a variable name, whenever we used to declare it. So here it's not required. Whenever we initialize a variable, for say example, a equal to 10, that is the only moment the variable is initialized and declared. It is because it is a Python is a loosely typed language. What we mean by loosely typed language is that at runtime we don't have to declare the data type of a variable. The interpreter of Python automatically understands based upon the value currently it is storing. So we'll see some examples of it. I'll also make some programs for all of you to just follow along. So hope my screen is visible. This also.
Yes, it is visible.
Okay. So let us see some Python programs, what we discussed just now regarding variables. So first thing which I mentioned was that we don't need to declare any variable. We don't need to write like int a equal to 5. This is not required in Python. We can just write a equal to 5 and that's enough. The variable has been declared. If for printing any variable or printing any value, we can just use a print command in Python. Now, if I run this program, we can have the value of C 5. So we don't need to write any. So we don't need to write any declaration before the variable name here. One more thing which I want to tell you is that these variables can change their type also in the course of action. Like a equal to 5, we are printing, it is an integer. We can also say a equal to John. This is also fine. The type has been changed and it will be handled automatically by Python itself. Let me run this program. See, 5 and John. In other languages like C++, C and Java, we cannot do that. Once a type has been declared, a variable cannot change in type. But since Python is a loosely typed language, it can change its type on runtime based on the data it has been storing all the way along. And one more thing in Python is that we can check the type of the variable. For example, let me just write here type. So it will show what is the type currently, which data type a variable is right now. So if I run this program, you can see it is of a class string. So currently the last stored value in the variable was a string value. So I hope this is clear till now. One more thing that we need to do is that variables are case sensitive here in Python. Like a equal to 5 and a equal to 10 are two different things here. So if we print a, it will give the value of the a variable. So a smaller a and a capital A will be two different variables. Let me just run and demonstrate. Yeah. So now, moving on, there are certain more functions with variable, like there are certain rules to declare a variable. We can only declare a variable starting with the alphabet. We cannot declare a variable starting from say one like this. This is not a legal variable name. A legal variable name can be something like this, starting from an alphabet, having an underscore, or numbers from 1 to 9. That's it. If any hyphen or any special character is used in a variable name, it will be a legal variable name. It will throw an error to you. Like for example, if I try 1 ABC as a variable name, and I just save it and I will try to run this program, it will throw an error, invalid syntax. See. So these are some rules for declaring a variable, and these are very common rules. We cannot use hyphen and any special characters here. There are certain more capabilities which are different from normal language which Python has in terms of variables. Firstly, we can declare multiple variables in a single line with multiple values. What I mean to say by this is, like, for example, I have three variables, x, y, and z, equal to, let me say, a, b, and c. So what this line means is x will have the value a, y will have the value b, and z will have the value c. I don't have to explicitly mention that x equal to a, y equal to b, and z equal to c. So this is a new feature of Python, that multiple values can be stored in multiple variables in a single line only. I'll just print these variables so that it will be clear for us. Yeah, you can see a, b, c. We just print x, y, and z. So this is another added feature. Plus there is an additional feature that same variable can multiple variables can also have the same value. So this is also a very interesting feature which Python has. What I mean to say by that is, if I say x equal to y equal to z equal to orange, for example, and I'll just use these statements only here. Now let us see what the value of xyz will be. See, all corresponds to orange. So it has both way functionalities, that one value can be assigned to multiple variables, or multiple as values can assign to multiple variables. Secondly, we have one more capability which we use on variables, is that it can unpack certain lists or arrays also. What I mean to say by this is, for example, I have a list example value. Say it will have 3 elements, A, B, C. So if I do like this, what this will do is that it will unpack this list example to x, y, z values. So this will contain A, B, and C. So Python has to dynamically destructure or to unpack its list into multiple variables if we are listing to it. If it had more than 3 items, this list, then the remaining rest items will be converted into Z, and the first 2 elements will be in X and Y. I hope this is clear to everyone. Like we can see in the output, A, B, C is being displayed as the list is getting destructured. So moving on from the variables. Now we have certain data types also in Python. Like I showed the type we were using to get the type of a variable. So these are some certain data types which we use in Python. Text type we use string, that is very common. For numeric types we use int, float, and complex. There is no double in Python. So, and in sequence types we use list, tuple, and range. Sequence types are nothing but data structures which are mapped by indexes starting from 0. Mapping type, we have a dictionary here. Set types are set and frozen set. What is a set type? This is a new type of data type that has been introduced in Python. Set types are nothing but these are fixed sets. Repetition is not allowed. These will always be ordered. These are some advanced data types which are being used in Python. For Boolean type, we use bool. Binary types, we have bytes, byte array, and memory view. What is the difference between a bytes and a byte array? Bytes, as we all know, contain a certain number of bits, like 8 bits, to be sure. So it will have a number of bytes in it. A byte can have a multiple number of, if we need to package our data, we can use byte array, and memory view shows how many bytes that particular variable is storing currently. So these are some of the data types which are being used in Python. Moving on, let's come to list. That what a list? It is a very important data type in Python, in day-to-day Python. If you want to develop programs or anything, we should have the knowledge of list. For again, I'll switch to code view for this. I'll explain you with the examples of list. Let me just introduce it to you first. In other languages, we have arrays. In C, C++, we used to declare arrays, but in Python, there is not a concept of array. Instead, we use list. There was one drawback with array in previous languages, was that array needs to be homogeneous. Like if we are declaring a integer array, all the elements of that array should be integer. We cannot store a string value per se in an integer array. But with list, this is not the case. It is not required for a list to be homogeneous. It can store multiple data types in a single list. It can have integers also. It can have strings also. It can have objects also. It can have a list of lists also. It can nest with dictionaries also. So whatever use case we have, we can use list as per our requirement there. And lists are mutable also. What we means mutable or unmutable in Python is that mutable data structures can be changed while in the course of program. Like we have declared a certain list and we can change its values. But a unmutable data structure, for example, sets, cannot, their value cannot be changed. Once declared, they behave like constants. Okay, so let me just share some examples for list and then we'll move to other. Is my screen visible? If anyone can confirm that my coding screen is visible, then I'll continue. Hello? Yeah, so continuing, we have, let me just declare a list here. Let me say apple, banana, orange. So what I have is here, I have a list with 4 elements: apple, banana, orange in list. This is how a list is declared. If
अब
we
example
say,
सुद्धा तेच घेते generator
if we say if we declare a variable with empty square bracket, it means it is a empty list. And if here we declare any elements for say 1, 2, 3, next element can be a string also. Like I discussed, that it is not needed to be homogeneous. It can be having multiple data types. So both these two lists are fine. Let us just quickly print this and see what is the result. So I'm printing both. As you can see, for the first one, we have our complete list, and for the second also, we have the complete list. So this is a very basic data structure that is being used in Python, and it has a lot of applications in Python. So we should have command on this. There are certain shorthands used for a list. Like right now, when I printed the list or the list variable, it printed all of the elements which has. For example, we had to print it backwards. We had to print it from cherry, orange, banana. Then we have a shorthand in Python. Just we need to give a -1 index in a square bracket for the list we have. Let me just print it and show. Yeah, see, we are having just the cherry here. So this is how we can declare. We can print in ranges also. Like if we want to show from banana to cherry or banana to orange, then what we can give a shorthand here is we can print something like this also. So let me just run it. See, banana, orange, and cherry. So these are some certain shorthands which are used with the list. These are called range functions. We can define a range of indexes which we need to print, or a range of index values which we need to print, and Python will handle it dynamically while printing. There are certain functions also which we have with list. Those are very helpful. Now suppose we wanted just to access banana or orange in the list, then we can directly give the index of that particular item or element. The index always start with 0. So if you want to print orange, then it will be 0, 1, and 2. So we can give it like this. See, orange is printed, just a single element. Okay, moving on. Now we saw how to print a list, how to print between ranges, how to declare a list. Now say we want to update the list. For example, I want to update from banana to, say, strawberry. So what we can do is we have certain methods. First, we can use the element index itself. Like I can say that the first index should be strawberry. So now let me just print the list and see what we get. See, now the banana has changed to be strawberry. This is how we can update our list. We can add, we can append to the list also. There is a
Excuse me,
function.
sir.
Yeah.
Sir, where is the output? I am not showing output. Only.
Can you see this?
Yes, sir.
This is the output of the current
No,
statement.
sir. I am not seeing. I am seeing only whatever program you are rewriting.
Okay, this screen is not visible.
No, sir.
The output screen. Okay.
No.
Yes, sir. Output screen is not visible.
Yeah, I'm so sorry for that. Now the output screen is visible.
No. Yes, sir.
Yeah, so you can see this. Now just I updated from strawberry, from banana. So these were all the outputs. So previously also it was not visible, the screen.
Yes, sir. Previously also only programming screen was visible.
Okay. So shall I go through it all once again? So I'll just give an overview. We printed some variables. These are those outputs. This was the type. And when we were doing unpacking and packing for multiple to one variable and one to multiple variable, these were the results of those prints. Right now we were doing list. These were the two lists we made and we printed those complete lists. This was for the range, for the from backward. This was for the range output from 2 to 5 or 2 to 4. This was for the single element when we give the index. Now just I updated the single index, one from banana to strawberry. Earlier you can see it was banana. Now since I updated, it's now strawberry. So this is how we can update our list. So now again, let me switch to the coding window. I hope my screen is visible. So now if we want to extend the list, if we want to add elements to the list, how we can do? Either we can give dynamically like list index 4, index 4 equal to say something guava. So this is also fine. This will also give the result. This will increase the length of the list by 1 and will add the element. Let me just show and run this. I'll share my program. That window also. Wait a minute. So what else we can use here is that we can also use a method called insert. These take two parameters. First, it will take the index to be inserted and the element. So the element was guava. So this will also work. I'll just run it and will share my window. Yeah. Is the screen visible?
Output screen is not visible. Yeah.
Huh?
Yeah.
So as you can see, the element is added at the end. So this is one method. Another method is append. So I'll show that also. What we can do is we can just write the list dot append and we can just give the element name. We can say blueberries. So this will also append the list. This will add in the list at the last. So this is also a command that is being used. This insert command can be used to update the values as well. If I give the guava to be as the say second element also, it will update. Let us see the result, what it shows. So let me just run it. Yeah. So this is the output. The output screen is visible. So firstly, it was having apple, strawberry, orange, cherry. Now, since I added on the second index guava, guava is being inserted on the second index. It increased the length. Now I appended blueberries at the end. So the blueberries are appended at the last. So these were some list operation we used to add certain elements or to increase the length of the list. Now, since we are adding, we should have knowledge to remove the elements also. So there are two very widely used methods which are used to remove the element from the list. First one is pop. If I say the list dot pop, what it will do is pop will remove the very last item of the element. So what it should do is it should remove blueberries from the list. So I'll again print the list and see what the result will be. Yeah. So here is the output screen. As you can see, blueberries were added, and when I used pop, the last element is being removed. One more application of the method pop is that we can give this particular index to remove. If I didn't want to remove the last item, and if for instance I said to remove the index 2, what we had on index 2, we had guava. So guava should be removed from the list. Let us just check the output quickly. Yeah, is screen visible? You can see guava has been removed from the list. Okay. So this is one method. Another method is called clear. It will empty the list. If I use the list dot clear, what it will do is it will clear the complete list. It will make the list empty. We'll just quickly check the output once for this also. Yeah, as you can see, the output is a empty list. So what I did nothing there. I just use the command the list dot clear, the method, and the list got cleared. So these were some of the methods which are being used to remove the item from the list. One more method is there, the list dot remove, that works same as the pop to remove the last element from the list. So these were all about the list. Is there any doubt regarding this topic? Anything till now, like variables and list, is if anything is not clear? Okay. So moving on. Yeah. Now we saw what lists were. Now there's another very important data type which we have. These are called dictionaries. What is a dictionary? Dictionary in Python is a sort of a JSON object, if we all have worked with it. Like dictionary contains key value pairs. It another term for it is associative arrays, which we may have used in different advanced languages like Java and PHP or JavaScript. So dictionaries in Python is nothing but a key value pair holder, which is an unordered collection of data values. Unordered means it does not necessarily means it should have been it should be in order or can be obtained by index, rather than it has to be obtained by keys. This for this also we'll do some examples, and then it will be very clear that how a key value pair holds in dictionary. What advantage a dictionary has is that it is very optimized because it is not obtained by indexes. So for example, we have 5,000 key value pairs. So we will know what the keys are. So we don't have to iterate over every index, and this is what makes it optimized. We can directly access that value using the key. Each key value pair in a dictionary is separated by a colon, whereas each key separated by a comma. Like this is a part of declaration. If you want to declare a dictionary, we'll say like something like car colon equal car colon. We say Maruti and comma, and then another key will be used. So let us just quickly dive into some examples so that it will be more clear. Uh, my programming screen is shared with you all.
Yes, sir, it is visible.
Yeah. So let me quickly just give an example of dictionary, how we can declare it. So for a dictionary, for a list, we saw that we were using square bracket. For dictionary, we'll use curly braces. And for example, let me just give like first key car. I said colon is used to differentiate between key and value, and my value will be like say Ford. Okay. And I can have multiple key value pairs in a single dictionary. I can say model, I can say Mustang. After comma, I can give another key value pair. I can say year, I will say 2021. So this is a simple dictionary. Let us just print this and check what the value is, how Python decodes this and gives the value to us. Yeah. So here you can see this is being printed in a value of key value pairs. Now, when I said that it is more optimized means one minute, let me share my programming screen. Yeah. When I said that it is more optimized than a list, is that we can use our keys to access any element. Right now, I printed the whole dictionary. What if I just wanted to know the value of car? So what I can do is I can just use car as my index to access the value of this dictionary. So in that way, it will not go and look up to each index. Like if I said 2, then normally internally what happens is that it goes to each index. It will go to 0, it will go to 1, and then when it reaches to 2, the value is being displayed. But in this, it shows a method of lookup. It will only search for car, a key which has car. So it will go to this and it will just display the corresponding value it has. So let us just quickly check. It is more optimized. That is why dictionaries are being used. As you can see, the value of car is being shown. Okay. So I hope this is clear. We'll see some more examples for dictionaries. As you know, we have similar examples for dictionaries as we have for list. We can also insert some elements to it, remove some elements for it. There are certain methods to get the value also. One, this is simple index method. Another method that is being used is a get method. So what we can do is this dictionary dot get, and here we can give the value of the key whichever we want. Like I want to get the value of model. So what this is, this will get the value of the key which is named as model. So we'll just save it and we'll just view. Yeah. As you can see, Mustang is being shown for the model. So these were some methods to display or to get the values of the dictionary. Now quickly let us just go through some examples how to add a value. So it is very similar to list. We can use dot append to add. It will increase the value. It will add it at the very last of the value. Before appending, let us view some other methods also. This dictionary dot keys, this will display all the keys a dictionary has. Right now we have declared a very small dictionary, but generally whenever we go into programming certain some lengthy programs, we'll have dictionaries which have a large number of keys. So just to look up the keys, we have a function called this dot keys, and for printing out the values only also we have a function called values. So what we can do is let us quickly check their outputs. Yeah. So when we use this dictionary dot keys, we have all the keys. When we use values, we have all the values. So these are some quick methods to display only values or keys, or to just to check if it has keys, what keys a dictionary has or what values a dictionary has, to model your program accordingly. So moving on, let us see. We can also display items also. Items in sense, it will give every key value pair as a separate item. So we can use that also. I'll quickly just show. Yeah. As you can see, the very last output, dictionary item. So every key value pair is being shown separately. So these were some quick methods for dictionaries. Moving on, as I mentioned that adding and removing are very similar from the list which we just discussed. So I'll move on to new topic now. After dictionaries, let us now understand that what white spaces and indentation in Python means. Uh, as you have seen, whatever we were doing till now, we didn't use any curly braces. Python doesn't have any curly braces or semicolon like we have in Java, C, C++, which were our foundation languages when we started coding. So instead, Python has certain rules for white space and an indentation, which I'll just quickly demonstrate in few lines here. Okay. So what Python says is that it will not use any curly braces, but it will use indentation to see whether a new block has been occurred or not. If I say that a equal to 5, and in this line I say print a. So what this means is, this is another line, this is another line. They both are two independent lines. They're not dependent on each other. But if I say if a greater than 10, and I want to write a print statement that if a is greater than, then print yes. Okay. So what this means is that this colon means a new block has been started. A new block for what? What our parenthesis or curly braces used to define? They used to define a code block. So in Python, colon defines a new block. And when we indent one tab space, means 4 spaces indent a line, it means this print statement is inside this if block. Okay. So let us just quickly verify this. A is not greater than 10, as we can see it's yes. So let us have a else statements also. Else print no. So see, this else is in indentation with this if. If I would give it as this, then this is not correct, because this if is not inside the if, this else is not inside the if block, which is not the correct syntax. So this should be in same indentation line, and this print statement is inside this else block, this no print statement. So let us quickly check the output so that it will be clear to us. Yeah, just done it. As you can see, no is being printed as 5 is not greater than 10. So this is now working as expected, right? What if I just de-indent it and keep it in the same indentation as else is? Now let us see what happens. See, it is throwing an error saying that unexpected indent block is there, because generally this print should be inside this else, and this else has an open block with empty statement. So that is why it is giving an error. To check it correctly, let us just remove this colon and do this and try to run our code. See, it said invalid syntax because if should have a code block to start with. So these are some white spacing and indentation rules that we need to follow in Python. I hope this is clear, because this is the basic of Python, and this is how we'll write our programs in future, by indenting itself. Okay. So I'll just move on to next topic. Next is that how we can do comments in our Python program. We can do it by giving a hashtag. So it will take it as a comment. For multi-line comments, we use 3 inverted commas for commenting. I'll just quickly show the example. Okay, one way is to have a comment like this with a hashtag. Another one is with the 3. For multi-line comments, we use 3 inverted commas. Here we can give multi-line comments. So these are 2 ways of commenting in Python. Again, moving on to next topic, we have operators. Now this is something to understand here. In our general knowledge, we use operators like double ampersand sign, double pipe sign, exclamation and equal to for not functions. In Python, we use statements only, like and, or, not. Like we had to say if a greater than 5 and a less than 10. So we will not use double ampersand sign here. We'll use the statement and. We'll see some examples also so that it will be clear. For identity operators, this is something new in Python. What is identity operator? It is used to check the instance of a variable. Like say a certain variable is the object of a class. So if you want to see that that same variable is the instance, or same that variable is the object of that class or not, we can use operators like is or is not. Membership operators in and not in shows the relation between the two variables. For example, we have a list which has elements like apple, banana and orange, and if I want to check that, if I'll declare a variable x equal to orange, I want to check that x is in orange or not. So I can use this operator that if x in fruits, fruit is my list. So if x will be there in fruits, so it shows the membership, the relation between the elements. We'll cover it with examples also when we are doing if statements and if else statements and loops. So now if statements. So let us jump to examples right away, and let us clear those things. Now let us start with a basic if example. We all know what if statements are. There control statement. They are used to just for any equality or inequality or a certain condition statement, and whether it's true or false, we can control our program or control the flow of our program like that. So let me declare a variable a equal to say 10 and b equal to say 15. And what I want to say is if, and let me declare c a variable as 5. Yeah. So what I want to say is if a greater than c, then print. Yes. This is a simple if statement we saw in our previous example also. This will obviously print yes, since a is greater than c, which has 10 and the value 5 respectively. So let me just quickly run this program and show you. Yeah. As you can see, yes is being printed. Now just let us now nest it with some operators which we just saw. And so what I said, that we'll not use double ampersand sign, we'll use statement simple and C less than B. Now this will be false. B is 15. It shouldn't print yes. Let us check. We'll run this. See, still showing yes. Okay. So this is how operators can be used in if statements. Now let me give an example of else statements also. So let me see if A greater than, let's say, C, which is true, then I'll say print yes, or I can say else print no, and I'll just change the value of A to 1. So this will be now false. So it should go in else statement. I'll just run this program quickly. Yeah. So as you can see, no is being displayed. So this is a simple syntax for a if else statement. Now for else if in Python, we use a different syntax, and this is called elif. So this was the else statement. If I want to use a different condition, then I'll have to use elif command, and I'll say if a equal to 1, then print a, for example. So let us check this value, what it prints. So this shows 1. Now I was talking about the membership operators also that we can use in if command. So let me have a list here, fruits. Yeah. And then let me have a variable x equal to orange. So what I can do is I can check if x in fruits. What this will see, this will see that if this value x lies in this or not. So in displays the relation between this x variable and fruits variable. What I can say is print let's say, let me just quickly run this program and see. We can have available is being displayed. On the contrary, if if I just say that x equal to some other fruit, say cherry. Now let us see if it prints or not. I'll just use a else statement here. So I'll just print not here. So let me just run the program and show you. Yeah, see, not is being printed now. So I think identity operator is also clear and if else is also clear. Okay, now moving on, we have the other topic which is called loops. So in Python, we have only two type of loops which we use majorly. These are while loops and for loops. So we'll quickly see some examples of while loops. While loop first check the condition, that as long as the condition is true, it will execute a certain block of program. So let us quickly see some examples for it. Let me say that a variable I equal to 0, and I'll say that while I less than 6, it will print I, and most importantly, I'll have to increment the value of I, otherwise this will run forever. This will be a infinite loop because I will always be less than 6 since I is declared as 0. So let me quickly run this program and see the result. Yeah. See here till 5 it is being printed. So this is a very basic example of a while loop. We'll try some more examples. Break statements are also being used. So what I can say is that while we can say that let me just remove this. While I less than 6, print I, and I'll say that if I equal to 3, break. So this type of nesting can also happen. What this will do is this will check that if the value of I is 3, then it will terminate the loop. So only the value till 3 should be displayed. After that, it shouldn't be displaying. So I'll just quickly run the program and check. Yeah. Yeah, I hope it's visible that only till 3 it is being displayed. And one more additional feature which Python has is using else statement with loops. Yeah. If I write a else statement here, so what will happen here when this block of execution, this block of code has been executed, then only after it will execute the else part. Else part, let else say print greater than 3. So let us just run it and check. Yeah. So this is also being displayed. So these were all about while loops. Similarly, we have for loops. For loops are also very similar as we use, but we don't use conventionally, like we declare a variable and then we declare a checking statement. So that is not how we write a for syntax in Python. There are two very simple syntaxes used. Let me just show you with example. For example, we have a list of fruits, say, for example, fruits. Say we have apple, we have orange, we have mango, say we have cherry, and say we have guava also. Okay, so this is a list. Now I want to traverse to each and every element of the list. So this can be done using a for loop. So I'll just say for x in fruits, and I'll just print x. So what this statement does is this will act as a for each loop. This will get the every index or every position or every item of that list and will print it. So this is a very simple syntax of a for loop. I'll just run the program and just show you the results. See, every fruit has been entered, every fruit has been printed one by one. So this is how for loops are being used. Similarly, for dictionaries also we can use this. And let's say if you want to run for numbers, I want to print numbers from 1 to say 6. So what I can do is I can use a range function. I can say for I in range 6. This will exclude 6 and will print till 5. So print till 5. So let us just see the output of this also. As you can see, till 5 it is being displayed. Certain more variations can be done in for loop also. Like here we were simply iterating over fruits. Another way of iterating over list or dictionary is for I, say in range, and we can just use length of that uh, length of the list, and what we can say is print fruits and that particular index. So according to our logic or according to our need, we can modify the working of our for loop here, and we can adjust to it to our requirements, and all the traditional nesting can be also done. See, the output is exactly similar what we use there. Yeah. So this is how loops are being used in Python. These were very simple examples. The normal nesting loop inside loop can also be used. For inside while inside for also can be used, and break, continue, or such statements can also be used with for loops. So yeah, that's it. So let us again come to our PPT. So this was for loops which I just explained. Now coming to Raspberry Pi in Python. Till now we saw the basics of Python, what Python, what were the basics of Python, how we can write simple codes in Python, how we can use if statements, looping statements in Python. Now in Raspberry Pi, Python is pre-installed. When we install Raspbian OS, Python is pre-installed in that, and since it is a Linux based, excuse me, it is a Linux based OS, so it works on Python predominantly, and the certain packages pre-installed. So first, let us see Thorny IDE. Raspberry Pi has a IDE which is called Thorny for development of for writing programs in Python. We can directly run Python programs there. We can write, and it will be a terminal just like I was using. It is very similar to that. It works on MicroPython architecture. MicroPython is nothing but Python which is similarly a slightly modified for running in low end devices, like say Raspberry Pi can run full Python, but say like ESP32 or ESP36. So for those also we can use MicroPython, and we can code in Raspberry Pi for such tools also. It is simple and very powerful tool. So we can go to programming section in our Raspberry Pi, and here we can see Thorny Python ID, and we can just open. So this is how the window looks. We can just start coding here, and we run. We can see the output in the same window at the bottom. So now let us discuss the GPIO code in Python, how we can access the GPIO of a Raspberry Pi using our Python code. So this is a very important line called import rpi.gpio as GPIO. What this line is doing, this is importing the GPIO module or GPIO package and importing the GPIO. So this is just a name which we can give. We can also write rpi.gpio, but again we have to write rpi.gpio everywhere we are using. So as GPIO means we are giving it as a name. We can say as X also, as Y also, it doesn't matter. It is just giving a name. So mostly this line is importing this package, and then we are importing time for sleep functions. So here we have declared our switch, declared our variables. LED is equal to 18, switch equal to 13. So I told you there is no data type required to declare a variable. This means that LED will hold the value 18 and switch will hold the value of 31. Right now this doesn't has any meaning. It's like these are just two simple variables which hold the value 18 and hold the value 31. Now, using GPIO commands, we can use the mode in which we are using the pin layout. In the previous session, ma'am also explained that there are two basic layouts, board and BCM. BCM, we have channels, and board means the current layout which the board has, the numbering board has. So now we'll set up our pins. Now this line GPIO.setup LED GPIO.out defines our pin. This means the 18th pin in our Raspberry Pi will act as an output pin. Similarly, the next line GPIO.setup switch GPIO in. This means the 31st pin of our board will act as an input. So this is clear till now. Now what we are just using, we are using a loop for I in range of 10, means 10 times this loop will occur. Okay. This loop will occur for 10 times, and this will just go on keeping the LED to high, then sleeping for 0.2 seconds, and again then using it for low. So it will just blink, and we can have the switch status also. So the input will also be printed what we are having the input from the switch. If I'm pressing, then it will say as 1. If we are not pressing it, then it will switch status as 0. And the last line GPIO cleanup will just remove all the values which we have set previously in our code. So it is a general practice to clean up our code after execution is finished. So the next command or the next code can rewrite it or initialize it again. So this was a basic program how we can access GPIO in Python. There are certain commands or certain methods which we use to know to start programming in Python. Like in the previous example, I use board. This is GPIO.BCM using set mode. When you use .bcm, then we will refer to GPIO numberings of a pin. So when I say LED equal to 4, then it means GPIO 4 and not the pin number 4 in the board. Okay, so this is the very basic difference between those. I discussed the GPIO setup command. It is used to determine a pin as an input or an output. And when we use as an output, we can also initialize it as a high or low. When we're initializing its output, the initial polarity of that pin. GPIO input takes pin or the reading of the input, and output, as we saw in the previous example, to set high and low of a particular pin. So yeah, this was all about the session. Any questions? Okay, then moving on.
Thank you, sir. Informative lecture. And thank you, Rita Jan ma'am, for your valuable knowledge and information. I hope all the participants are very much benefited by your lecture. And this is the time to queries. If anybody is having any query in their mind, they can ask. Yes, anybody?
Okay, madam, next session timing bata dijiye.
Very much clear to everyone. Vikas sir. Vikas sir. So, okay, thank you, sir. Thank you for your time and your efforts putting us for sharing our knowledge. Thank you, ma'am. So, participants, we will meet again after 25 minutes. Okay, so the session will start again at 2:40. For that, you can take a break. Again, we will meet at 2:40. Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Okay, sir. So now we are going to end our meeting and we will meet again at 2:40. So
Thank you,
participants, take the break for your lunch.
Welcome, Abhiganam sir.
Yes, thank you so much.
Okay, welcome back all the participants in our today's third session. I hope you all have taken your lunch and joined the session with full of energy. Okay, so now I would like to call Mr. Abhigyanam Giri to give knowledge on IoT device designing methodology with hands-on. Before that, I would like to introduce Abhigyanam sir. Mr. Abhigyanam Giri carries with his array of experience which range from IT professional to corporate trainer. He is highly motivated and experienced in training small and large groups across diverse industries. Proven success in leveraging educational theories and methodology to design, develop, and deliver successful training programs and integrate instructional technology to provide on-site and virtual training. Possesses excellent presentation and communication skills. Having more than 15 years of experience in the field of training and development, he had conducted training in more than 100 colleges and trained 20,000 plus students and faculty as well. In different streams across Pan India, he had awarded for most prominent contribution in the field of training and development in Central India. Under his leadership, company received Best Training Company Award by the former Education Minister of Madhya Pradesh. He had completed MTech in VLSI design and BTech in electronics and communication. His core competency in technical training, curriculum development, software installation and configuration, testing and quality assurance, web-based training, system diagnostic and troubleshooting in both software and hardware. He has experience on IoT, artificial intelligence, Arduino, Raspberry Pi, advanced robotics, wireless control system, DTMF control system, embedded system, PCB designing, etc. Welcome, sir.
Okay, so I'm Abhigyanam. Let me introduce myself first. I'm Abhigyanam Giri, working as a training head with Hyundai's Infotech Private Limited. And before I start the session, I would like to thank TIT Group as well as Mr. Dr. Vikas Gupta sir for inviting me as a speaker for this session. I would also like to thank all the respected faculty members who are attending this session. And what we are going to do in this session, let me tell you these things first. Like within like 15 to 20 minutes, I'll introduce IoT to you. Obviously, each and everyone knows about this technology in these days, but still I'll start from very basic thing. So we'll start from basic things like introducing what is IoT and all, and then what are the basic criteria or what are the basic requirement is there to design any IoT device or like products, and then hands-on. Like I'm having IoT kits with me right away. So this is the kit which I'm going to use this in this live session to develop different kind of products or project, we can say, or prototype, we can say that. So this is how we are going to proceed in this session. So before I like start the session, I just want to once more confirm that am I audible properly to each and everyone, or is there a voice break or something like that? Divya ma'am, is there everything?
You are audible, sir.
Okay, fine. So let me without wasting any further time, let me start the session. And if we get additional time in the later, then we'll discuss all additional things. So okay, now I'm going to share the screen, and hopefully you all can see this slide, Internet of Things concept.
Yes, sir. Your slide is visible.
Yeah, it's visible. Okay. So in this session, we are going to see, I won't say learn, because obviously, all the faculty members are very experienced here. I can see that. But still, we will see these things, starting from definition part, then what are the application need of IoT. And this is the main thing, like how to design any IoT prototype. So this is, we'll give more time in this section, but we'll start from the definition part. So let's see what is IoT. Obviously, each and everyone knows, but I'll start from very basic. IoT is nothing but it's a technology in which we connect physical objects with a network. Like if we connect computers or laptop with a network. That network is called as internet, right? With the help of internet only, now we are able to conduct this kind of session. I don't know, but approx 84 participants are here right now in this meeting, and everyone is in different place, most probably. So Internet of Things is the network of physical objects, and those objects can be a device, vehicle, building, and other item embedded with electronics, software, sensors, and network connectivity. So because of that, these objects will collect and exchange data. So this is the very, very basic definition of IoT, when we connect physical objects, non-living things, along with the physical living things with a network, so that they can communicate, they can exchange information, and those objects can be a device like our cell phone, washing machine, bulb, fan. All these things comes under this part. Vehicles like our cars, buses, all these things comes under this. So all these things are, when these things are connected with a network, so that is known as IoT. So before I proceed, I would like to play a video. In this video, we'll see different kind of IoT application in our day-to-day life, so that it will be easy for us to understand the concept. So let's watch this video. It will take hardly 5 minutes to watch this complete video, and then we'll continue the session. Okay, so that's all in this video. So using like in this video, we have seen so many applications of IoT, and we have seen how these physical objects are connected together to exchange information and different kind of data with themselves. So ultimately, because of that, these physical objects like devices and vehicle building are able to communicate with each other. So this is IoT actually, and I don't want to waste further time in this definition part. So let's go ahead. Before I proceed, I just want to cross check. Am I audible, ma'am? Divya, ma'am?
Yes, sir, you are properly audible and your site.
Okay, fine. Thank you. So application, let's see the application where we use these IoT products. We have seen a very common man's life in this particular video, day-to-day life applications of IoT, but still IoT products are used in healthcare. It has been used in agriculture industry, smart devices, industries, education sector. So no, like not a single sector will remain in future that won't use IoT products. Each and every sector, trust me, each and every sector will use different kind of IoT product according to the requirement. So what is the need of IoT? Let's see that. Because of IoT, the physical devices, like these objects will collaborate, they will interact, they will share experience, and they can exchange data. So what is the basic difference? Actually, what I'm doing, I'm covering these things very soon because I want to give more time in designing part. That's why I'm covering these things as soon as possible. So what is the basic difference between internet and Internet of Things? Internet is what? When we connect computers, when we connect millions of computers worldwide with a network that is known as internet. More than 190 countries are linked into exchange of data, news, and opinion with the help of internet. So that is internet actually. But what is IoT? What is Internet of Things? When we connect physical objects and devices with a network that is known as IoT. So that's done. Now this part is also done. Need is also done. Now let's go to the main topic, that is designing part. How we can design IoT products or prototypes. So before anybody want to start designing, they need to understand and they need to finalize what should be the objective of that product, because without knowing the objective, nobody can design anything. It's very natural that you need to understand what basically you want to design, what will be the purpose of your product. So same way, in if you talk about IoT, you need to decide the objective or aim of the product. This will be the basic thing, means important factor. According to that, you have to design the hardware part, because suppose as for example, if you are planning to make a robot, then obviously IoT based robot, then obviously you need to use motors. Without motors you can't design any kind of robot. So you have to decide the objective. According to the objective, you need to use the different kind of hardware components. So basically you have to design the hardware. Then to control the entire hardware, to give some kind of output according to the input, you need to write the code, and that is nothing but the software. So you have to design the hardware, you have to design the software, and then your product should communicate with external world, because this is a IoT product. So your product, IoT product, should communicate with external world from any part of the world. So you need to connect that with a network. So these three things are combined together to design any IoT device: hardware along with software, and that then network is connected. So hardware, software, network, these three things are connected together to design any IoT device. That's what we are going to do in this session also. What we are going to do, we will design the hardware part, we'll design the program also, we'll merge those two things, and then we'll provide a network to that, to that device, so that it can be controlled from any part of the world. So let's go ahead and check out what is the hardware part. Suppose we have decided, we have finalized the objective of our product, IoT product, then you have to decide the hardware part. So let's see what is the hardware part. Obviously, each and everyone knows about it, but let me explain this part also. What is hardware? Hardware is nothing but the combination of different electronic components. It can be a sensor, it can be LED, it can be like different kind of LCD displays, it can be a motor. Yes, one thing is compulsory, that is a controller board. Because without controller board, nobody can design any IoT product. Why it is important? Because to process your code, to save or store your program, or to process your code, you need a central processing unit, CPU, and that is available in the controller boards. So if you don't have the controller board in your project, then obviously you don't have the software, means you don't have the program, and without program, how you can design any IoT product? Having a program is compulsory while designing any IoT product. So that's what I'm trying to explain. These things like sensors or LEDs or these jumper wires or like capacitor, transistors, diodes, different ICs, these are the optional component according to the requirement, according to the product which you are designing. You have to decide which component you are planning to use. That is the different thing. But whatever you are designing, whatsoever your product is, you need to use one of the controller board that I'm going to explain very soon. So this is the hardware part, actually the physical components. The circuit component comes under this hardware part. Now let's see what is the software part. Software part is nothing but the code or program. With the help of code program, your hardware works. Obviously, it takes the decision. It takes the decision when it will give some kind of output according to the code or program only. So we need to write some kind of program. So we have so many choices. We have C, C++, programming languages, Python. So it depends upon the hardware and what you have the knowledge of the program. According to that, you can select any language and to write the program. So obviously, we need a program for that. So software is nothing but your program. And network. What is network? Communication between smart IoT objects. So you need to use one of the network like Wi-Fi or internet or something like that, or Bluetooth. So it depends upon you which kind of network you are going to use. So these three things are combined together. Circuit component with program is connected with a network to design any IoT system. Now the second part, suppose you have decided each and everything till here you have decided. Now the next step is to decide which controller board you are planning to use, because there are so many controller boards. Yeah, that is a different thing that I just told you, that without controller board we can't design any IoT system. So it depends upon you that which controller board you are comfortable with. So these are the very popular controller board in India. Actually, Arduino is one of the very popular board which everyone uses for IoT device designing. Second one is Raspberry Pi. Third one is Node MCU, and so many other boards are also available. These are the very popular names actually, but other boards are also there. So what is the basic difference between these controller boards? Like this Arduino has, if you are planning to use Arduino, then you need to use external Wi-Fi module, because you can't connect, again I'm telling you, you can't connect Arduino with internet directly, because it doesn't have any Ethernet cable slot where you can plug Ethernet or LAN cable. It doesn't have any Wi-Fi module inbuilt so that you can connect this Arduino board with Wi-Fi. So if you are planning to use Arduino, then you need to use additional Wi-Fi module to connect with the internet, because if you can't connect with the internet, how you can design IoT product? So Arduino has this drawback actually. Arduino has this drawback. What is the what is Raspberry Pi? Actually, Raspberry Pi is a kind of mini computer. You can connect monitor, keyboard, mouse with this, and very, very popular board actually. But it is costly actually. It is costly. So we can go ahead and we can select this node MCU. This node MCU, why node MCU is preferred for basic project designing? Because it is very cheap as compared to Raspberry Pi. It has an inbuilt Wi-Fi also. It has inbuilt Wi-Fi so that you can connect this with internet directly using Wi-Fi. So that's why it is very popular. So what I'm going to actually, I had so many choices to use during this live session. I would have used Arduino or I would have used Raspberry Pi, but I'm going to use this Node MCU while for designing different kind of IoT projects during this session. So let me summarize till here. If we are planning, anybody wants to design any kind of IoT product or prototype, then first step is to decide the objective. Then the second step is you have to decide which controller board you are going to use according to the application. Means if you need larger memory or something like that, which is not there inside Arduino or Node MCU, then obviously you can prefer Raspberry Pi. It has a larger memory as compared to these boards. But if you have a very basic project in which these memories are enough for you, then obviously you can go ahead and you can use this one, because these boards are much cheaper than Raspberry Pi. Okay, so suppose we have finalized that we are going to use this Node MCU board. It looks like this actually. This is the view of Node MCU, and here we can see the pin names like D0, D1, D2, D3, D4, D5, D6. These are our digital input output pins. As we all know, what are the digital input output pins? It means we can have only two values on these pins, either logic high or logic low. Only two values are possible. Other than that, no third values will be there on these pins. What is logic high in case of Node MCU? It's 3.3 volt. In case of Node MCU, in case of Arduino, actually 5 volt. It gives 5 volt on the output pin. But in case of Node MCU, 3.3 volt is there. But that is obviously considered as a logic high only. And what is 0 volt? Logic 0, that is 0 volt. So if you are using any kind of input output peripherals like LEDs or a buzzer or relay or something like that, which works on digital values, then you can connect those peripherals with these pins only: D0, D1, D2, D3, D4, D5, D6, D7, D8, and these are RX-TX pin for serial communication. What is serial communication? If you are sending data, 4-bit, 5-bit, 8-bit data using a single pin, then this TX pin can be used. It can be used to send a complete 8-bit data or 5-bit or 6-bit data using a single pin. So that's why it is called serial communication. And if you're receiving some data, suppose you have connected RFID or Bluetooth, which sends serial data to your microcontroller, then you can use this RX pin to connect with RFID or Bluetooth to receive the serial communication data. So these are two serial communication pin. And these are the pins that start with D is your digital input output pins. We can connect LEDs, motors, buzzer, 7-segment, relays using these pins only. We have only one analog input pin to connect analog sensors like temperature sensor, analog temperature sensor, or humidity sensor. Obviously, few digital temperature humidity sensors are also available these days. Very popular name is DHT11. That gives digital output actually, but temperature sensors like LM35, yes, LM35, it gives analog voltage. The voltage can be anything in between 0 to 3.3 volt. So those kind of sensors which gives analog data can be connected using this pin A0. And these are some other pins which are not required here. I'm not going to explain these pins here because we are going to use only digital pins in this live session. So yeah, it has an inbuilt Wi-Fi here to connect directly with the internet. So let's see what is the definition of Node MCU. It's an open source development board. Open source means we can use this board for learning purpose. We can use this board for even commercial purpose. Even our company has designed a few projects which we sell in the market and that is based on Node MCU. So there is nothing of license or something by license for that. So that's why it is called as open source development board that helps you to build your IoT projects. It's like Arduino only, like Arduino board. Like Arduino, it has also input output pins. Yeah, like it has inbuilt microcontroller also, but it has a Wi-Fi built in. It has inbuilt Wi-Fi to connect directly with the internet, and that Arduino doesn't have. So this is the very important feature of Node MCU. It has an inbuilt Wi-Fi. You don't need to buy any additional Wi-Fi module to connect with the internet. So I'm going to use this board only in this live session. So these are the like total 30 pins are there. If you count 15 this side, 15 this side, total 30 pins will be there inside Node MCU board. D0, D1, D2 are the digital input output pins. Only two values will be possible there, logic high or logic low, that is 3.3 volt or 0 volt, either 3.3 volt or 0 volt. Only two possibilities will be there. A0 is the only analog input pin to connect with analog sensors. This is not the output pin, it's an input pin. But yeah, we can define these pins as input or output. It's our choice. Suppose we are connecting these pins with a sensor, like fire sensor, then we will configure this D1 pin as a input pin. Suppose D0 pin is connected with a LED, then this pin will be configured as an output pin. So it depends upon the user, it depends upon the developer, pin he wants or he or she wants to use as an input or output. It can be configured as an input output. It's your choice. There is a command for that. So this is the basic introduction of Node MCU. Now, in this live session, the first project which I'm going to design in front of everyone is the first project is IoT based notice board. So as I've already told or informed that before going further, before deciding the hardware or before writing any kind of something like that, you have to finalize, you have to decide what will be the outcome, what will be the objective, what will be the aim of your project. So the aim of our project, which we are going to design in this live session, is IoT based notice board. What it will do, the data sent from any remote location, from any part of the world, it can be in India, out of India, anywhere, from anywhere. Obviously internet should be there. So data sent from any remote location will be displayed on the LCD. This is the first project which I'm going to design, and if we'll get time, we'll design few more projects also during this session. So it can serve as a notice board or information display system on which we can display our data sent through internet. See why it can be considered as a notice board. Suppose we have fixed this project inside a classroom, because most of the attendees are from different colleges. So we can obviously consider this example. Suppose we have fixed a LCD in all the classrooms, and suppose HOD sir or ma'am wants to send some kind of information to the students. So he or she just needs to send some kind of data from the cell phone. He will write the data. Within a second, it will be displayed there. And it is not compulsory that he or she should be remain in the college premises only. He can send this data from any part of the world. That's why we can consider this as a notice board. So like this is the aim, or this is the objective of our project. Now let's go ahead and check out the hardware requirement for designing this project. So again, I'm going to ask Divya, I'm really sorry. I just want to confirm. Am I like, is this clear? Like voice is clear?
Yes, sir. Your voice is clear.
Okay, fine. Thank you so much.
Thank you, sir.
Now, let's go ahead and check out the hardware requirement. So basically, because obviously we can use Raspberry Pi, we can use Arduino, we can use any other controller also. Because I'm going to use this Node MCU, that's why I have considered this example. So Node MCU will be used because whatever code you will write, that will be stored inside this Node MCU only. And this Wi-Fi module will help this entire board to connect with the internet and receive data through the internet. And then using your code, using your program, you can display your data on this LCD. So that's why the controller unit which we are going to use is this Node MCU. LCD will be used. Obviously, we can use like larger size LCDs also, but obviously coding will be different and it will be more complex as compared to this. That's why I have just considered this alphanumeric LCD just to display alphabets or numbers. But we can use graphical LCDs also. We can use monitors also. We have already designed, our company have already designed a project in which we can display anything like images or text on the monitor or TV from any part of the world. You just need to type, or you just need to upload the photo of notice board. Suppose like some kind of notice is there, you just need to upload that photo in the application which we have developed, and within a second it will be displayed on the LCD or TV or monitor, whatever you have used. And text, obviously text is also possible. Just type the text and send, it will be displayed there. So that is a different different advanced version of notice board. But here in this session, I'm going to use this one, alphanumeric LCD. And why buzzer is used? Buzzer will be used to just to give the notification alert. We can say that alert. Whenever new data will arrive, this buzzer will generate sound. So we are using this buzzer thing, that's for alerting purpose. Okay, so basically these three things will be combined together. So let us see how they will be connected together, how this node MC will be connected to LCD, and then how this buzzer will be connected to node MCU. Because each and everything, like these are the output peripherals, like buzzer or LCD, these are the output peripherals. These will be connected with your controller board only. So let's see the circuit connection for that. So I'm going to use this connection for this project. I'm going to use D0, D1, D2, D3, D4, D5 to connect with our LCD. And I'm going to use D8 pin to connect with our buzzer. So one question will arise. Maybe I don't know how many people are thinking about that. So where is pin number 1 of LCD? Where is pin number 2 of LCD? Where is pin number 3? Where is 5? You have mentioned 4 and 6, but where is 5 number pin? So let me tell you that thing also. If you look at the data sheet of a 16 by 2 LCD, alphanumeric LCD, you'll see that there will be total 16 pins. Even after this, we'll have this image. Yes, we have this image. Starting from this pin number 1, ma'am, is it visible? This pin number 1 is written here or 16 is written here. Is this visible on the screen? Because I can see that.
No, sir, it is not visible. Just wait, sir. Yes. Sir, it is not visible. The number is not visible.
Okay, but can we see this LCD entire?
Yes,
LCD?
sir. Yes, sir. The LCD panel is showing.
Okay, so I'll just like tell this is the pin number 1 actually. Starting from here, this is pin number 1. Cursor is visible.
Yes, sir. Cursor is visible.
Yeah. So this is the pin number 1, and this is the pin number 16. So when we see the data sheet of LCD, we'll see that pin number 1 is connected to ground. Always it should be connected to ground. And pin number 2 should be connected to 5 volt to provide power supply to the LCD. Again, I'm telling you, pin number 1 should be connected to ground. Pin number 2 should be connected to 5 volt to provide power supply to the LCD. So that's why I have not mentioned that thing, because I'm just mentioning the pins which will be connected to node MC only. Yeah, let me tell you 3 number also. Pin number 3 is a contrast adjust pin that should be connected with a potentiometer, pot, variable resistor. So we can change the contrast. If the data is not visible properly on the LCD, we can change the contrast of it using this pin number 3. So variable resistor is connected through pin number 3. 4 number, obviously this is register select pin. It should be connected with your controller. It can be Arduino, it can be Node MC, it can be Raspberry Pi. So pin number 4 should be connected to your RS pin. It is known as a register select pin. It should be connected to controller. Pin number 5, read write pin, should be connected with ground. That's why I have not mentioned here. I have not mentioned RW pin here. And pin number 6, enable pin should be connected with your controller. 7, 8, 9, 10 not connected from anywhere. If you are working in 4-bit mode, I'm working on 4-bit mode. That's why 7, 8, 9, 10 not connected anywhere. 15 is LED plus pin. 15 is LED plus pin that should be connected to 5 volt, and 16 is connected to ground to give the power supply to the backlight to make it on. So that's why if you see this now, if you see this, I have just mentioned the pins which should be connected to your controller. I have not mentioned those pins which should be connected to either 5 volt, ground, or variable resistor, something like that. So using datasheet, you can connect those pins also. So 4, 6, 11, 12, 13, 14 should be connected with D0 to D5. Yeah, it's our choice actually. We can use D1 to D6 also, D2 to D7 also. It's our choice actually. So I have just considered that D0 to D5 will be connected with the pins which should be connected with your controller, LCD pins. And yes, D8 pin will be connected with a buzzer. So this is the circuit connection which we are going to use. So this is the hardware part actually. Hardware part is over. Now let's see the software part. So inside software part, we need to have basically two things. One is the compiler. What is the compiler? Where you will write your code and check the errors, and which is used to upload your code into the controller board. So I'm going to use this Arduino IDE software. It is also open source. It can be downloaded from their website, arduino.cc website. This is free actually. You don't need to pay anything. So I'm going to use this Arduino IDE software to upload or compile or check the error of our program. So this is the software view, how it looks. This is your coding area. This is the status area where we'll see the errors. And this is the command bar. The first option, the first tick mark is used to check the error. Second one is to upload your code. If you want to upload your code into the board, you need to click on this. Third one is to save your project. Fourth one is to open your previous project. No, the last one is to save your project actually. So these are the basic few important things which we need to have. And code. Yes, let's see the coding part. Let me just show you this code. But after we'll get the output, after we'll get the correct output, then I'll explain this code, because after we'll get the output, no, it will be easy to understand. So it starts from this header file, include liquidcrystal.h. Here you have to mention, the pins which you are using to connect with the LCD. So I have, according to the hardware, I'm using D0 to D5, and these three header files will be written here. What is auth token? Auth token will get on our email ID whenever we will create a project on the application. So the application will give or provide a auth token or on our email ID. We just need to copy and paste here. And SSID and password. SSID password, internet means you need to provide Wi-Fi or internet connect your board. So here you have to mention the nearby hotspot or Wi-Fi name and password, so that your board will use this credential to connect with the internet. And after that, directly your program will jump to void setup. Actually, I'm explaining this code in brief, and after we get the output, I'll come back again here and then explain this code in detail. So here you will configure your D8 pin as an output pin. Why D8 pin is configured as output pin? Because we have connected a buzzer through that pin. So you have to configure that pin as an output pin. Now serial begin 9600 baud. 9600 is the baud rate that is used to see our text or information on the serial monitor. So that's why you have to configure that serial communication. LCD begin 16:2. Here 16 indicates the columns available. Total 16 columns are there on the LCD, and 2 rows means we have 2 lines to display our data. So 16 columns, 2 rows. To activate your 16:2 LCD, you have to write this command, lcd.begin. And this command, blink.begin, will cross-check or verify whether your auth token is correct or not, SSID is correct or not, and password is correct or not. So if all the three things are correct, then your program will come here on this part, void loop. And here it will continuously connect with the Blink server. Actually, I'm going to use Blink application to send our data. So it will be connected with your Blink server, and it will remain here. But once you send your data from your cell phone from any part of the world, it will come to this function, blink_v0. And then it will call this function, buzzer function. And here what we have done, we have put logic high on D8 pin. Digital write means you are writing value logic high on D8 pins. So because of that, the buzzer will start generating the sound for next 3 seconds. So after 3 seconds, it will stop, so that it will give kind of alert to you that we have received a new data. So you can see the LCD. So after executing this buzz function, your program will come back here, and then it will execute .lcd.clear command. What is lcd.clear? To clear the data on the LCD. And then lcd.setCursor 0, 0. This is the cursor position where exactly you want to display your data. 0 means 0 column, 0 means row 0, means whatever data you will display will be displayed on the first line left corner. Suppose you want to display data in the middle, then you have to change the column position here, like 4 or 5 you have to write, 4 column, 5th column, something like that. It will start from there. And suppose if you want to display your data in the next line, means below line, then you need to write 1 here, because this is row 0. Row 0 means the first, row 1 is the second line. So you need to write 1 here. And then lcd.print, parameter as a string. Whatever data you have received as a string from the internet will be displayed on the LCD. So briefly, actually, I have explained this entire thing, but after we'll get the output, we'll come back here and I'll explain this code once again. So no worries. So this is the coding part. So coding part is done. Compiler, I have already explained that I'm going to use this Arduino IDE software or compiler, and you need to connect that with the internet. So where exactly I'm going to demonstrate, or where exactly I'm going to run this program, that I'm going to show you just now. I'm going to use this board. We call this board as a EB, IoT by You. Actually, in the market, we can get different components separately. We can get LCD, we can get relay, we can get node MCU, we can get ultrasonic sensor. But what we have done, our company has done, we have designed a printed circuit board according to like our requirement, and we have put almost each and every basic component in the board itself. So ma'am, please respond. Is this visible? LED section is visible here? LED 1, LED 2, LED 3, LED
Yes, sir. Yes, sir. It is visible.
Okay, fine. Thank you. Let me see whether I can zoom this thing. Yeah, I can zoom this thing. So what we have done, we have put our node MCU controller unit in the left corner here, so that we can connect a data cable and we can program this. And all the components like LEDs, 7 segment, this is 16 by 2 LCD, relay unit, buzzer, temperature sensor, buttons, LDR unit, and this is L293D to connect with our motors. All these things we have put on the board itself, and we have given these pins in this line. Suppose if you want to control your LED using D0 pin, what you have to do, just put your code or upload your code in this code and connect a cable through this D0 pin, bring a wire from this D0. Here we have D0 pin of our node MCU. Connect this with some of the LED, like 4 LEDs are there, LED 1, LED 2. Is this name visible? LED 1, LED 2, LED 3, LED 4. So suppose if you want to glow this LED 1, then you just connect this D0 with LED 1. But I'm going to design IoT based notice board. So here we have these 6 pins. RS, enable, D4 is nothing but 11 number pin of our LCD, 11, 12, 13, 14. So only 6 pins we have provided here that should be connected with your controller. And this is your variable resistor. I just explained that variable resistor will be used to change the contrast of your LCD. So this is the variable resistor. And remaining things like 5 volt ground, we have provided internally on the PCB itself. We have provided those things internally. So this is the board which I'm going to use to design our project. This is our IB board, Internet of Things IoT by You board. And we sell this board online also. And we also use this board for training purpose. So anybody would like to answer this, where we should connect this RS, enable, D4, D5, D6, D7 according to the circuit which I have explained? Anybody would like to say this? Just for interaction, I just want to listen. Like these pins, these 6 pins, LCD 4th number pin, LCD 6th number pin, LCD 11 number pin, LCD 12, 13, 14, where we should connect these 6 pins with our controller. Anybody would like to say this? Because I just explained this thing.
D1
yes.
to D6, D1 to D6.
Actually, we can connect D1 to D6, sir. But according to the circuit diagram, which I had explained, I was using D0 to D5, if you remember.
Okay. Yes, sir.
Yes, sir. You said
But yes, but it's yes, you can use D1 to D6, but you need to change the code also.
Yes.
Otherwise, it will not work. Okay. So this is the hardware unit, and I just need time just to configure each and everything. So I'm going to stop sharing the screen for a minute, and then we'll come back within a minute, because I need to prepare the hardware and I need to prepare the code also. Okay. So please be online. Just give me a second. No, not second. Just give me a minute, actually. Yeah, now I'm ready with the code. And again, I share this screen. So is this visible? Is this visible? This Arduino
yes,
ID
sir.
software?
Yes, sir. Yes, sir.
Okay, okay. So let me put my code, or let me create a new project, and let me put my code here. Yes, and let me bring these 3 details, actually, the Wi-Fi name, password, and auth token, which I have already received on my email ID. So yeah, now I'll open this thing entire, and let me replace that thing. Wi-Fi credential, set password, this for open network. If you have an open network, you just don't need to write any password. So this is the code, actually, I was explaining. It start with header file, and then here you have to mention your pins of your node MCU, which you will connect with your LCD. And these are the 3 header files. And auth token. Yes, let me show you the mail, actually. Actually, I have received auth token on my email ID, actually. The Blink server, this Blink server will send a auth token on your email ID. So this is the auth token which I have already received on my email ID. But before I proceed, I just want to tell you that this is not the only one application which we can use. There are several n number of applications available these days which we can use to connect hardware with internet. There are so many cloud applications, like Arduino Cloud is there. Arduino Cloud, very popular, actually. Arduino is very popular, but they have now developed a Arduino Cloud software through which you can program your controller boards, and through which you can control your board or your hardware from any part of the world. Similarly, other applications are also there. ThingSpeak is there, Firebase is there. So many other applications are also there. But I'm going to, I had to use some kind of one of the applications. So I'm using Blink application. So I'll share the screen on my mobile also, and we'll show you how we can create a project on the Blink application also. But before that, I just want to show this code. So this is the auth token, which anybody, means once you will download your Blink application from the Play Store or App Store, and once you will create a project there, you will definitely get a auth token on your email ID. Just copy and paste in this code. That's it. And then this is the Blink write function. This is the void setup function. And I have written additional line, actually, before doing anything. I've just written this notice board. LCD.print notice board thing, that it will be displayed by default. It will be displayed on the notice board, so that we will see that, okay, notice board is displaying. And this is the code. So what next? See, our code is ready. I'll connect a cable USB cable and connect with the hardware. And then we need to check out the Node MCU board. Means other boards are also there, like Arduino, UNO, Nano, and all these boards are there. ESP8266 base boards are also there. Lolin, VMOS, Node MCU, all these boards are. I told you, there are so many boards are available these days. So we are using Node MCU. That's why you need to select Node MCU and which COM port you are using to connect with your Node MCU. You need to connect that thing also. And then after doing all these things, just click on upload. So once you click on upload, this software is obviously free. You can download this software from the website. And let me save this project on the desktop, and I'll name this project as Notice Board. So Notice Board I have written, and just click on save. Hardly it will take a minute or 2 minutes. So it has started compiling the sketch. Compiling sketch means it is checking the error, whether there is error in your code or not, because IoT is a combination of hardware. IoT is a combination of hardware, software, and internet. So you need to have an internet connectivity in your home or office, wherever your hardware is there. So you need to provide that internet connectivity. Along with that, you need to have a program. So this is the program. Hardly 10 to 15 lines code is there for designing a notice board project. So you should have this code, and obviously you need to have a hardware. So hardware I'm having with me, which we have already developed, and this is the code which I have written, and I'm uploading. This is the method to upload this code into the hardware, because once you will upload the code, then only it will work. So let's see. Writing at this speed. We need to wait for 100%. It means it is uploaded. Now it is uploaded. We can see this message, done uploading. Done uploading means we have successfully uploaded this entire code into the hardware. Okay. So now the next step is to verify whether your board is connected to the internet or not. So you need to check the serial monitor. Click serial monitor and press the reset button on the board itself. Connecting to MyAbhi. This is the Wi-Fi name actually. Yes. Now we can see this Blink logo on this serial monitor. And ma'am, is this visible ready message?
Yes, sir.
Yeah. So ready indicates that your board is connected to the internet. Now you are sure that obviously it is connected to internet, and now you can check the output. So what next? To explain this entire concept, because I have shown the code, I have shown the hardware, but I haven't shown the application part, the application through which we can send the data. So for that, I will connect my phone actually in this meeting. I need 2 minutes time. I'll join this meeting using my phone also, so that I can share my phone screen and can explain the application part also. So please be online. Just give me 2 minutes to connect with my phone. So let me.
Sir, is this your number 91277? Yes. So is this your number? By this number you have joined?
No, I'm joining. I haven't joined now.
Okay.
So let me, meanwhile, let me summarize this entire concept. Meanwhile, we are designing IoT-based notice board in this session. And for that, we need basically hardware. So we can use any hardware for our purpose. So we are using Node MCU, and we are using EB board for getting the output. And we need to have a code also. So I have written a code, and I have successfully uploaded that code into the board, hardware board. The next thing is you need to use, next thing you need to use is your application. There are so many applications. I just named them. ThingSpeak is there, Firebase is there. So many other applications are also there. But I'm using one of the application which is very easy to understand, which is very easy to use, and that is known as Blink application. So why I'm trying to connect with my phone, because to explain this Blink application, I need to show the screen, entire screen, my phone screen, so that everyone will understand how we can use that application. So let me see the meeting code. It's 532814256. Is this the code? Yeah. Please, ma'am, allow, you'll see Indai's name only.
Sir, yes, sir.
I think now I have joined. Okay. So
To make you co-host, otherwise you cannot share.
yes, that's what I was trying. Please allow me so that I can share the screen. Ma'am, can you allow me?
Yes, sir. Now you can share, sir.
Yes. Now I can share. I can see that. And I've started sharing the screen also. Is this visible?
Yes, sir. This is visible.
Okay, so let me explain this entire concept. I have opened this Blink application. I have downloaded this from App Store. Yeah. And this is the view of this Node Blink application actually. And this is the method how we can create after installing the software. This window will appear like this. Ma'am, can you see this new project window, new project and all?
Yes, sir.
Okay, so we need to click on this new project first, and then we can give name anything like IoT or my project, something like that. And here we have to select the board, like so many boards. It is there, so many options are there, but we have to use this Node MCU. So you have to select this Node MCU from here, and your Node MCU will be connected with Wi-Fi. That's why you need to select Wi-Fi. Dark light theme, it depends upon you. And then you need to click on create project. So once you click on create project, this message will appear that auth token has been sent to your email ID, something like that. So after that, you just copy that auth token and put inside your report. That I've already done, actually, already done using this project, NodeMCU project. Now, in this project, you can select the widget from this options, like button is there, style button is there, slider is there. Sorry. Is this visible? Can no screen broadcasting. Okay. I need to share once again. Kya? Got disconnected, I suppose. This is the problem if we use our phone for showing the output in the live session, actually. So anybody can call meanwhile and gets disconnected. Mostly customer care numbers. We have got a chat message for okay. 1 2 3 4 5 6 7 8 is the password. Ma'am, please allow me.
Okay,
And
sir.
again, please make me co-host.
Yes, sir. Just a minute. Sir, now you can.
Yes, yes. Yeah, it's visible now, I think. So yeah, I was saying that we'll get the widget option from this option. Still syncing. Yeah. So from here we have to select option called as terminal option. So let me select this terminal option and then tap on this terminal, and we need to select virtual pin 0. Why virtual pin 0? Because in my program I have mentioned virtual pin 0 only. Suppose you have selected virtual pin 5, then you have to select virtual pin 5. So I'll select virtual pin 0 from here and then OK. Click on OK. That's it. You don't need to do any other changes. Just select virtual pin 0 and then click on OK. So now this widget has been connected with virtual pin 0. And the next thing which we need is to connect the hardware part. Means this Blink application is ready to use, actually. Created the project, send the auth token on our email ID, and we have selected the widget which we are going to use, and we have connected that virtual pin with terminal option. So that's all from this Blink application part. Now I have to show the hardware, actually. So just give me a minute so that I can connect the hardware also. Just give me a second. Yeah. Okay, so now I'm having this hardware with me. Is this visible?
Yes, sir. This is visible.
So what I need to do, I need to connect D0 to D5 with LCD pins because code has been uploaded successfully. Blink application is ready. I just need to connect D0 to D5 with LCD pins. So hardly it will take a minute and then we'll see the output. I have connected D0 with RS pin, that is pin number 4 of our LCD, D1 with enable pin, D2 pin with 11 number pin of our LCD, that is also known as D4 pin, data 4 pin, D3 pin with pin number 12 of our LCD. That's what actually I'm doing. Then D4 pin with pin number 13 according to the circuit diagram which I had already explained, and D5 pin with pin number 14 of our LCD. So now 6 pins are connected. One more pin we need. Can you tell me which one more pin we need and for what purpose? Which one more pin is needed? D0 to D5 we have connected with our LCD. Which one more pin is needed?
For grounding?
For output?
For grounding? I'm not sure.
Ground we have already connected. Ground we have already connected through this PCB. D8 pin buzzer. D8 pin buzzer. Yes. D8 pin buzzer. So buzzer pin also there on the board itself. Just connect buzzer. And now I'm ready with the output. Yeah, it's visible. I don't know whether it will be visible properly or not, but still I'll try. Can you see notice board written on that?
Yes, sir.
Is this visible notice board?
Yes, sir.
Okay, so the first part, the very important part, actually, I always worry in live session. Let me tell you this honestly, because these hardware can work like anything. It can behave anything like that. So I'm always worried in the live session whether it will give the output or not. Whether this some of the jumper wire is maybe it is bad or something like that. So obviously we will not get the output. But once we'll get this some kind of text here, it means all the jumper wires are correct. It is working perfectly fine. LCD is working perfectly fine. Coding is working perfectly fine. So now I'm sure that we will get the output. Now, second thing which we need, I'm having this phone with me. So we need to open that same Blink application. I just actually I shared the screen. So this is the Blink application. Can you see this terminal option? Terminal option. Is this visible? Terminal option.
Sir, not properly.
Okay. थोड़ा मैं नजदीक से दिखा देता हूँ.
Yes, sir.
ठीक है. So the same thing. If you people want, I can share the screen from the phone also, so that you can also see. So why not? But let's get first output as soon as possible. So I'll type thank you everyone for attending this session, but I can't write more than that. I just can write thank you everyone because 16 characters only we can display 16 characters. We can display only 16 characters. That's why thank you everyone. D8 pin is connected with buzzer, fine. And I'll just click on send from this option, send. But it is Just give me a second. Okay, so we are getting the output. Yeah, we are getting the output. Let me show you. Let me write something like hello, and let me send on through my phone this data hello. Can you hear the sound of the buzzer first for a 3-second time approx?
Yes, sir.
Yes, sir.
And then after 3 seconds, let me show you what is written here. Is it visible?
Yes, sir. Hello.
Hello. So the same thing I have typed on the phone. Hello. Can you see hello is written there?
Yes, sir.
So both the things, actually Internet of Things, we are using IoT concept to send the data. Actually, it's not compulsory that I should remain here like 5 meters or 10 meters far from the hardware, because this data has been sent to the board through the server, Blink server. So I can go anywhere. I can be anywhere, like the same city, the same country, or even different country also. And I can keep this phone with me, because this Blink application has been connected with the hardware. So I can keep this with me. I can send data from any part of the world. So one more data I'll send. Thank you, everyone. Thank you, everyone. And let me send. So obviously the buzzer generates the sound for 3 seconds approx. And I have sent this. I don't know whether it is visible or not. Thank you, everyone.
Yes, sir.
Is
Visible.
this visible, ma'am?
Yes, sir. Visible.
So this is thank you everyone. Thank you everyone. And here we can see the output. Thank you everyone. So this is how we have developed one project. So we have half an hour time left. So we will develop few more projects also. So I just want to wait here for 2 minutes time. I don't know how I'm conducting the session. I really don't know. So all the faculty members are very experienced. So if you can suggest anything, if you want to suggest anything, please feel free. Or if you want to ask anything, you can ask me. Otherwise, I'll develop 2 to 3 more projects in next half an hour, because most of the time I take for basic concepts, that is done. So obviously it will take less time to complete 2 or 3 more projects. So is there any feedback, or is there any suggestion, or is there any queries? If you don't have, at least tell me no, so that I can proceed with that.
Yes, participants. Anybody is having any query in their mind, they can ask to sir.
Good evening, sir. This is Aarti. I just want to ask you one thing. Am I audible?
Yes.
Yeah, okay. First of all, thank you so much for giving a wonderful session. The Blink app you told me, so from wherever we can send a message to that board, right? So is it that means even if I'm having the Blink app, shall I send a message to that board? That means I have to write some IP address or something. I have to link it and I have to send it like that.
Very important, a very good question actually. See, so many people can have Android or iPhone, and so many people can have Blink application installed in their phone. But that auth token, which we will receive on our email ID, will be responsible to connect your phone with the hardware. No other phone or no other person will be able to send the data or communicate. We can say that communicate with the hardware which you are using. That is very important for security or privacy purpose. So what is the option? Suppose if you have designed some kind of automation in your house, like if you want to control the entire house with your voice command or your phone, and if you have this concept suggests that only one phone will be connected with the hardware. But what they do, they have given in the project section, they have given a barcode. They provide barcode. You need to scan the barcode. Other people like your family members or your friends, they need to scan the barcode and install the same project. Then even they can control the hardware, they can communicate with the hardware, but no third party will be able to do that randomly. And that is very important for security purpose. Is this clear?
Yeah. Okay,
is this
sir.
the question?
Yeah. Yes. Thank you so much. And it is restricted to any number of devices that should connect with that. Is there anything like that?
Not restricted. Means
Ah.
n number of devices. Even what you can do, you can use multiple phone with the same email ID. Just log in the Blink application or any application which you are using. Log in through the same email ID.
Okay, so I can.
Obviously, each and every phone will be able to control this hardware. Even right now also, because we don't have time, otherwise I would have asked you, I would have given my login credential, and even I would have asked you to send the data from your place. I don't know where are you right now, like in which city?
Yeah, okay sir, thank you so much.
In which city right now you are? Am I audible?
Yeah, I am in Chennai.
Okay, so even from Chennai also, if you will get time in the last phase of the session, so if you will get time, I'll give you the login credential. Just log in through that credential. Even from Chennai also, you can send the data here.
Okay.
It will work. It will definitely work.
Okay. Thank you so much.
So this is the first project we have got the output for this. This is the hardware. In which we are not using this entire components. We are just using one controller board, that is NodeMCU, to upload our code, to process the code, to execute our code, to connect with the internet. This is very important, brain of this entire system. This is the LCD just to display our data, and this is buzzer. So we are using only these three things together. We are not using other components. This is the hardware. I'm using one Blink application, which is there on the App Store and Play Store. You can download it and you can use it. We can use other options also. And now the third thing which we need is the software. I'll take hardly 2 minutes time to explain the code. I'll take just 2 minutes time to explain the code, and then we'll move ahead and we'll design at least 2 or 3 more projects because we have almost half an hour left for this session. Because after getting the output, it will be easy for me to explain this entire code. So now I have shared the screen. Is this visible to you all?
Yes, sir, it is.
Yeah. So the code starts with the header file because we are using so many commands like lcd.clear or lcd set cursor or lcd print, and all these command details are written inside this header file. So if you don't include it, it will you'll get error in your code. And here you have to, this is the format to mention your pins. We are using D0 to D5, that's why you have to mention these pins here. This command, this define blink print serial, is used to display Blink logo. If you remember, Blink logo is displayed on the serial monitor, so it is used here. If you want, you can ignore it, you can remove it, no problem. Output, you'll get the output. We are using the internal Wi-Fi of our NodeMCU, and the name of the Wi-Fi is ESP8266 Wi-Fi module. So you need to include its header file because you can't see the detail in this code, but so many commands are used about this ESP8266 inside the library. So you as a user, you can't see that. That's why you need to include it. And we are connecting our Blink application, that is of free is connected with ESP8266. That's why you need to include header file also. Here you have to mention your auth token. You will get on email ID. Here you have to provide the Wi-Fi credential. Very easy. Just you need to add these 3 things only. Nothing apart from that. Just 3 things. Okay. And then your program will directly jump to void setup. Here you have to configure your D8 pin as output pin, serial begin to print your serial data. It is very important to see whether your board is connected to internet or not. You can use this serial monitor. You have activated your LCD 16:2, 16 columns, 2 rows, blink begin to verify whether your auth SSID and password are correct or not. And then your program will display notice board. And if you are getting notice board, it means your wiring is correct, your connections are correct. Now you can be sure that you will get the output. Very important statement. Then your program will stay here. It will always stay here until you send the data. So once you send the data, your program will come here, blink_right, virtual pin 1, virtual pin 0. It's your choice actually. Actually, I told you that virtual pin 0 we are using, but while I was not getting, if you remember, I was not getting the output. So I just cross-checked that what is my code. I saw that this virtual pin I have mentioned here. So in the Blink application also, I changed the virtual pin 1 and then I started getting the output. Then your program will go to call this function, buzz function. Your buzzer will generate sound for 3 seconds. Clear the LCD, previous data deleted, and then set cursor where exactly you want to display. And then whatever data you have received will be stored here actually, parameter as a string. And that you will display on the LCD. So this is the first project. Now I'm going to stop sharing the screen. And let me show some different outputs now. Okay, so I think I should share my mobile phone screen so that it will be much more visible, because on camera it's not visible properly. So 875 3281 4256. Ma'am, please allow me to enter this meeting.
Yes, sir.
And please make me co-host also.
Yes, sir. Sir, now you can share.
Yeah, I can share now. Okay, so this is nothing. Now it's visible. This Blink application. This Blink application window is now visible. So we started with hello, then thank you everyone. We displayed. So now we have already got the output, so we can delete this widget from here. So I have deleted it. Now we can bring so many other widgets also from here. So many other widgets like button. So let me bring a button from here and let me tap it, and let's select D7 pin, which we are not using actually. So let me select D7 pin and push switch. It's your choice. If you want, you can use push mode. If you want, you can use switch mode. So let me select this switch mode. Nothing else you need to change. Just select the pin which you want to control. So I want to control D7 pin. I want to make it low and high using internet. Means from any part of the world, I want to make it, I want to change the status of that pin, D7 pin. It should be basically 0. The value of that D7 pin will be 0 basically by default. But when you press the button from anywhere, it will remain 1, means 3.3 volt. So just click on OK from here and click on play. So you should see this message online since 4 o'clock. Means if if it is offline, then just cross check whether your board is connected to internet or not, Wi-Fi is on or not. So you need to check that. So it's online, very nice. And then I think I should open the camera also so that you can see the hardware. Now what I'll do, I'll connect D7 pin with one of the LEDs. 4 LEDs we have given on the board itself. So I have connected D7 pin with the LED, and both the things are, I think, visible now. Both the things visible, means camera, this board, as well as the application part. Is this visible? Both the things, camera as well as the Blink application?
Yes, sir.
So you can see that LED is off. 4 LEDs are there. All the 4 LEDs are off. Now let me make it on from the Blink application. And within a second, it didn't take much more than that. Within a second, can you see that LED is now on? Is this visible? LED is now on.
Yes, sir.
We can see on the application also. We can see in the application also, as well as in the hardware also. Now let's make it off. So just click on off. So within a second, it's off now. So basically, what we are doing, we are not controlling the LED. If you understand, we are controlling the value or voltage on that D7 pin. So basically the value of D7 pin is 0 volt, but once you press the button, it becomes 3.3 volt, and that value goes to LED and LED becomes on. So obviously we can change it. We can suppose we want to control the buzzer from any part of the world. So just I disconnected with LED and connected with buzzer. Okay, so I just want to make I want to on the alarm. Suppose LED buzzer is your alarm. So just click on it. Obviously buzzer generates sound. Let's make it off. So now we are able to control this buzzer also from this button option. So this is how we can use button option to provide logic high, logic low to any digital pin, and we can connect anything with that. If you are using 2 buttons, then you can even control a motor also. If you are using single pin, then you can connect a LED, buzzer, or relay also. Last thing, no, 2 more projects I'll cover. It won't take much time. We have one option called timer also. Suppose you want to set some kind of time that at this time this pin will become high, and this time it will automatically will become low. So you just need to set the time. Same pin I'll use, D7 pin, and let's select the time. Now it's 4. What is the time on my phone? 4:19. Okay, so let me select this 4:20 p.m. on, and 4 just give me a second. It's already 4:20 actually. 4:22. 4:22 off. 4:21 on. 4:21 on, 4:22 off, and just click on play. So I just click on play. 4:21 on, 4:21 on, 4:22 off. So let me connect with LED. Otherwise, for a minute, the buzzer will generate sound continuously. It's already 4:21. So let me connect LED with that. So for a minute, it will remain on. Automatically, it will become off. So let's see whether it becomes off or not. So basically what I'm trying to say, we have so many different widgets available in this Blink application. We can use widgets like timer to control the pin at a certain time, and we can make it off at a certain time. So still it's 4:21 and LED is also on. Let's wait for 4:22. Yeah, it's 4:22 now. 4:22 now, and now it control any widgets with the help of timer option. So last project I'm going to design is smart bulb. I'm going to design the next project is smart bulb. Smart bulb means we can control our bulb or light from any part of the real light, means not LED and all, real bulb or real tube light or anything like that, or fan from any part of the world. So I need just 2 minutes time to do all the setup. I'm having this bulb with me. If you can see, is this visible? Is this visible?
Yes, sir.
So this is the bulb. So I'll connect, and this is the wire which I'll connect on the power socket. So this is the bulb, and these two wires will connect on the relay on the hardware side, and then I'll control this bulb from the application. So please give me 1 minute time so that I can do the setup part. Sir, okay, am I audible?
Yes, sir, you are audible.
Okay, so let me show you the hardware actually. I don't know whether it's visible properly or not. So can we see this bulb?
Yes, sir.
So let me connect this with a relay pin. I'll explain the complete concept. So I have connected with D7 pin. No server, stay online. Let me check. Relay is working. So I just need a minute time to verify why it's not behaving properly. Actually, server is not connected. So it's 4:27. Just 2 minutes time, please. Yes. Am I audible?
Yes,
Yes,
sir.
sir.
Yeah. Now server has been connected, and so the status of the button which I'm using on the Blink application is off. You can see this off. Is this visible? Off.
Yes, sir.
So it's off. Actually, bulb is off. But when I'll click on this button, this blink button.
दिखवा दिया तो क्या किया जाए? क्या?
Yes. So if even you can see this on here, I have make it on, and you can see the lighting that now it has become on. And when I'll put this off, I'll click on this off. Now it will become off. So now actually it's really complicated me to show this entire thing. So this is the setup actually I'm using. This hardware I have connected with a relay. This is the relay part, and through that I have bulb is connected. So let me show a image to explain this entire concept, how we can design a smart bulb. I hope this code is visible to you. And yeah, this is the image. Is this image visible to you all? Is this image is visible?
Yes, sir.
Yes, sir.
Basically, we are using this relay module to control 220 volt appliances, because our controller can't give 220 volt AC. They can only give 3.3 volt. So this relay module needs 3.3 volt logic. So instead of using D1, I'm using D7 pin actually. So when I'm sending data high on D7 pin, the logic is given to the relay module. And what it does, it connects this common pin with NO pin. So, and bulb is connected like this. One AC supply wire goes to bulb directly, and second wire goes through the relay, through this relay. So when this common pin, middle one pin, is connected with NO pin, when you give logic high, so the supply is connected to the supply is given to this bulb, both the wires. So bulb becomes on, and when you give logic low, so it gets disconnected and it is connected to NC pin. So that's why the bulb becomes off. So this is how it works, smart bulb. So this is all from my side. It's 4:32, 2 minutes late actually, but no problem. This is all from my side. I'm ready for the query session now.
Thank you,
Hope
sir.
you learn something.
Yes, any
Yeah.
participant? Anybody is having query? Participants, you can ask questions. Yes, sir. I hope everything is clear to them.
I don't know why nobody is responding. At least because most of the attendees are faculty members, respected faculty members. They can give suggestion to me also, because I'm also very I'm kind of learner in this field. So please feel free to suggest anything to me.
Participants, please. This is a very interactive session. You can ask and you can give your suggestions also.
Generally, it happens when students attend the session, they don't want to speak up. Students are also attending, yeah?
No, sir. All the members, all the participants are faculties.
Okay. Okay, Vinay Pant, sir. Okay, thank you, sir. So please, if you have any queries or any suggestion to me, please feel free to tell that.
Sir, if you want to share your email ID and all.
Yes, definitely.
For the participant, you can share.
Yes, I'm on the chat box. I'm providing my number.
Yes.
So if you want to organize any kind of technical session or workshop in your college, online, offline, then obviously you can contact me. Email ID also given, mobile number is also given, and the website, our company website, I'm giving indice.com. So all the three things, email ID, yeah.
Thank you, sir, for this interactive, informative, and interesting session. I hope faculty members are definitely benefited and they will get needed help with this session. Sir, I think Vikas sir, are you there? Vikas sir? Okay, sir. So I'm going to conclude the session. Okay, sir. Thank you. Thank you for being with us, and thank you for all the participants for listening patiently and attending all the session very patiently. So I'm again sharing the feedback link in the chat box. If anybody cannot fill the form, they can fill the form.
Thank you so much. I can see the feedback on the chat box.
Yes, sir. We are getting so much feedbacks.
Yes, I can see. Thank you so much. Obviously, it means a lot for me. Yes, sir. Thank you so much, sir. Because it's really tough and complicated to explain the technical subject like IoT, which needs hardware online actually. Online, we can obviously explain Python, C, C++, Java, because obviously we need to have a software and open the program, explain the program, that's it. But to have a hardware like this, show this on camera, again come back to the software part, show the software, all three things, to coordinate all with these three things, it's really tough as a speaker, but still I tried my best.
The session is very interactive and very interesting.
Yes, thank you.
Hello, good evening. Just I want to say, sir, the whole thing you managed very nicely. Just आपने अभी बोला, just you had managed whole thing very nicely.
Okay, okay.
And the way you have delivered the lecture, it is very nice. If it is online, so it is very effective to the faculty member as well as to the student also. Thank you, sir, and thank you all. So being a participant, I will मतलब आज बहुत अच्छा फील हो रहा है आपका ये सारा देख करके. ऑफलाइन भी अगर करने का चांस मिलता है तो it will be very nice.
आप कहाँ से हैं? कौन से कॉलेज से हैं?
I am Varsha Gupta from GTBIT, IP University, Delhi.
Okay, okay. ठीक है. तो प्लीज आप लोग इनवाइट कीजिए हम लोगों को आपके कॉलेज. We will definitely come.
Of course, बिल्कुल. We will definitely try for it.
Sir, one of the advantage of online session is that participant can be attend from all over India.
Yes, और मैं अगर आप में से कुछ लोग हैं जो चाहते हैं कि मैं मतलब कोई ऑर्गेनाइज करना है कोई सेशन, सो प्लीज प्रोवाइड मी योर कॉन्टैक्ट नंबर, या फिर मैंने जो नंबर दिया उस पे आप मुझे आफ्टर द सेशन प्लीज कॉल मी, सो दैट वी कैन कोऑर्डिनेट कि कैसे आगे फर्दर कैसे वी कैन प्लान. आई हैव गिवन माय नंबर अगेन. आई एम गिविंग. यस, because I don't have your like आप लोगों का जो भी faculty members हैं, आप लोगों का contact I don't have. I can't contact.
Sir,
thank you, sir.
Please share your PPT so that we can provide our participants. Are you having any PPT?
PPT क्या किस टाइप का चाहिए?
Sir,
जो था वो मैंने आपको बताया.
Hands-on session, but if you are having any PPT for that programming and all.
स्टूडेंट्स के लिए तो ठीक रहेगा. स्टिल मैं काम करता हूँ, मैं प्रिपेयर कर लेता हूँ. I'll prepare kind of PPT and then share with Vikas sir, and then he can share with all the participants.
Yes, sir.
Whatever I have like done, I'll make a PDF kind of thing, and I'll definitely prepare.
Okay, sir.
Yes, Poonam Chauhan ma'am. Yes, sure. Okay, so we can now end this meeting, I hope so.
Yes, sir.
Okay, thank you.
Thank you, sir. Thank you so much. I hope all the participants have filled the form. So we are now going to end the meeting. Okay, sir. Thank you, sir. You can leave, sir.
Okay, ma'am. Thank you.